Hello everybody, welcome to Math Academy and I am Nikhil. So in this video we shall be looking into the chapter matrices, and this will be a one shot video. That means that we will be covering the whole topics in the chapter matrices in a single video. But that doesn't mean that we will be skipping topics and completing the video very quickly. It just means that this single video will contain all the topics that is to be covered with a certain number of problems, a minimum number of problems. So you can consider it like a revision for the whole chapter. Alright, so let's, without wasting much time, let's go into the chapter. So we are starting off with the chapter matrices. So let's see what is a matrix. A matrix is basically an arrangement of rows and columns. It is an arrangement of rows and columns. So basically when we actually sit in a class, say for example if you are actually sitting in your classroom, not in the classroom that is considered to be online, I'm considering the school level classrooms. If you're sitting in a classroom, you can see that there will be a lot of benches that will be kept, and the students will be sitting in each of these benches. Say sometimes it might be 3 students per bench, or sometimes it might be 2, or sometimes you might be having individual chairs, or whatever it may be. It depends upon the classroom or the state of the classroom, right? So in such situations you can see that you can have certain called as, these are called as rows, and these will be called as columns. Say consider you're seating in a cinema theater. You might be many of you, all of you might have gone for films in theaters, and when you go to a theater you can see that the seats will be arranged like this: 1 2 3 4 5 6, and again behind 1 2 3 4 5 6, and exactly it will go on like this, right? So that means that you will have rows and you will have columns. That is the idea. So matrix is going to be a collection of rows and columns. In such, basically how do we represent, that is the idea of matrices. Let's see how do you represent a matrix. A matrix is generally represented with the help of a capital letter. We generally use capital letters for representing we don't generally use small letters, instead we use capital letters. I hope you remember what we studied in the chapter sets. Sets are generally represented with the help of capital letters. Similarly, matrices are also represented with the help of capital letters, and they will be written inside square brackets, and inside square brackets. That means that it will be written inside square brackets. Now let's see an example. So it will look something like this: A is equal to, and something like this. So it will be, I'll just mark certain positions. So these lines represent the position of the elements, all right, of the matrices. That means that, say for instance, I'm having numbers as elements of this matrix. So this is going to be 1 2 3 4 5 6, and you can see that this is the name of the matrix, which is going to be in capital letters. It will be kept inside the square bracket. So this is the square bracket, and I said it will have certain rows and columns. You can see this happens to be your first row, this happens to be your second row, and this will be your first column, second column, and third column. So they are arranged in such a way that it forms rows and columns. They are not randomly arranged. Instead they are arranged in rows and columns. Is that idea clear till how what is a matrix and how it is represented? I hope that logic is clear. Now we'll learn a term called as elements of a matrix. What is it called as? Elements of a matrix. I think it is not clear right now. I'll just rewrite the whole thing again. It is called as elements of a matrix. Now let's see what is called as elements of a matrix. Elements of a matrix is what is present inside the matrix. Say for instance, you can see this is going to be one of the elements, this is going to be my another element, this is another element. Exactly like this you can place whatever you want inside a matrix. Say for instance, if you are taking a theater, you can see that the people who are sitting on the chair is going to be your element, if you consider the whole theater as a matrix. That means that sometimes there will be a person on the seat, sometimes there will be a person, no person on the seat. So that is the idea. So in such situations, if you are sitting in a class, if you are considering a class, you can see that in a class you can see the person who are sitting on each and every position. So if I'm taking, these are my benches and these will be the position of students, then each of these position will be called as the element of the matrix. So that is the idea. I hope you are able to understand the concept. So each element, exactly like the element that you see in the sets, all right? And these elements can be elements of a matrix. I hope you understood what is the elements of a matrix. These elements can be letters, it can be numbers, it can be actually pretty much anything in my opinion. It can be pretty much anything. It can be letters, it can be numbers, it can be people, it can be anything at all. Depending upon the situation, we can interpret it in such a sense. All right. So I hope the concept of matrix is clear and what is it. And let's think about why do you study about matrices? What is the purpose of matrix? What is the application of matrix? Because when you study mathematics, it is very important that you understand the purpose of studying something, whether this is going to be used in real world. What you have to understand is that anything that you see in the real world has its applications in mathematics. It will have a root in mathematics. Everything that you see today is going to be a collection of a lot of science subjects. See, if you take your camera, for instance, if you take your mobile phone, it is going to be a collection of physics, chemistry, biology, mathematics. A lot of subjects will come in, and all these things combined together will actually result in a product that is sitting in your hand. So what we will be doing is we will help you to understand what is the purpose of matrices in the real world, and we will start from the history of matrices and slowly we'll come. But for doing that, we need to actually understand what a matrix is. So I'll just give you the brief on the places where it was applied, and then after completing the chapter, I'll show to you how it was applied. Alright, so that's it. So let's first see what are the different applications of matrices, different kinds of applications. Oh, I'm sorry, I'll just rewrite the whole thing for you. Application of matrices in which all areas. So let's see the application. So it was very much used in the concept of developing computer programs. And I'm not talking about coding, because there is something different between developing computer programs and coding. So that means that if you develop something called as a C++ or something like that, it involves, or the developing of a computer language involves the use of matrices, because basically the idea is it helps solving in equations. It helps solve equations. Okay, so just once the concept of matrices was introduced, actually the introduction of matrices actually started or kick-started the idea of computer itself. You know, the concept of computer itself started to come, or it started to evolve once the concept of matrices get involved. Then it has its roots in the concept of coding and decoding. All right, it is very much used in coding and decoding. That means that when we actually send messages, you know, in military warfare situations, in Second World War and all, matrices was very much used in order to send messages from one person to another person. That means that it is like, I see, when that means that if you have a letter, it was not like you will not send messages via something, you know, you will only use radio waves, and it can be interpreted by anyone, it can be interfered by anyone. So what happens is that when I talk to you, and if I don't use a code language, what happens is that the person who is hearing it out, you know, sometimes many people can overhear messages, or a person who is carrying the message can be caught. So what happens is that the enemy will get all the information. For that, for ensuring that the enemy doesn't get any information, we will use codes. So the concept of matrices was used in order to transfer information from one place to another place using the concept of codes, and the same matrices will be used, or same concept of matrices was used for decoding, and that is how information was spent. Say for instance, if you want to bomb a particular place, the coordinates of the latitude and the longitude would be given sent in the form of a particular numbers, and that will not be the right number that you need, but that will be converted, and that kind of some form of conversions can be done with the help of matrices. I'll explain how it was used in a later case. Alright, so that is the most important application, and it was actually, as I said, it helped in computing a lot. You know, I'll just explain this. Computing itself is going to be a huge area, so I think these two are enough. Two of them is enough. Rest I actually leave it to you to think yourself and try to identify the places where matrices are used. Alright, so that's it. So it is the application of matrices, and once it is clear, now let's go on and understand the definition of matrix from our NCERT textbook itself. So let's look at the definition of matrices that is present in our NCERT textbook, and the definition says a matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called as elements of the entries of the matrix. So that means that there is a term called as elements, and it shapes the shape of a rectangle. So you can see that in the definition of matrices, I said we'll have rows and columns, and the rows and columns end up forming a rectangle, and that is what is mentioned in the definition here. And you can see that rectangular array, it can be numbers or functions. As I said, it can be pretty much anything, to be practical. In a mathematical sense, it can be either numbers or functions. It can also be variables or anything like that. So the numbers you'll see as we go forward. So you can see three different examples that has been given here. where A, the matrix A is having the numbers. You can see these are the first column, this is the first row, this is the second row, and this is the third row. That means that how many rows does it have? It has 3 rows. This is the first column, this is the second column. So how many columns? 2 columns. In this question you can see this is a complex number, this is a decimal, these are integers, this is an irrational number. So anything can be made into this. This is a fraction, that is a rational number. So anything can be made, as I said. So again, this has first row, second row, and third row, and this is going to be first column, second column, and third column. That is how it functions. And the third matrix, you can see it is going to be the first row and the second row. You can see first column, second column, and third column. So these are the examples of matrices, and you can also note that they are written with the help of capital letters. The naming given is capital letters, and they are always kept inside the square brackets. All right. So I hope the pattern and the look and feel of the matrix is very much clear. Now let's move on and see the next topic, which is called as order of a matrix. Let's look at the next topic, which is called as order of a matrix. Now what do you mean by order of a matrix? Order of a matrix actually gives you the idea about the number of rows and columns in a matrix. What does it give? It gives you an idea about the number of rows and columns in a matrix. Number of rows and columns in a matrix. So let's see how they actually do that. Let's see how actually it does that. It does by giving you a way in which this data is represented, that is given by the name of m cross n. This is what we read it. We don't, even though we write it as m into n, we read it as m cross n. It is pretty much similar to a cross b that you have studied in your physics. All right. In physics you might have studied about the concept of vector product, and it is the same concept that applies here. The vector product, you read it as a, you write it as a into b, and you read it as a cross b. Similarly, you write it as m into n, but you read it as m cross n, and where m happens to be the number of rows. What does it? M represents the number of rows, and n represents the number of columns. I'm sorry, please wait. Yes, it represents the number of columns. That means that if a matrix has, say, m rows and n columns, then we say that the order of the matrix is m by n, or m cross n. In another words, if you say this one, if you take this matrix, say for instance matrix A, you can see that it has how many rows? 1, 2, and 3. That means that the number of rows is equal to 3. So in this question you can say the number of rows is equal to 3. Now let's talk about the number of columns. How many columns does it have? It is going to be 1 and 2. So that means that the number of columns is equal to 2. So what is going to be the order of the matrix? You can see the order of the matrix is generally it is equal to 3 cross 2. It is also read as 3 by 2. I'm really sorry about that. I just missed mentioning it here. Some of the books, some of the people actually read as m cross n. Some of them read as m by n. Even though you write it as m into n, you read it as m by n. Is that idea clear to you? So it is, in a way, it can be represented as 3 by 2 matrix, or you can say 3 cross 2 matrix. So 3 by 2 is more commonly used. All right. So it is going to be called as a 3 by 2 matrix. So again, this is going to be, you can see what is going to be the number of rows and columns here. We can see it is going to have 1, 2, and 3. So the number of rows is going to be equal to 3. And let's see about the number of columns. You can see 1, 2, and 3. This is going to be the number of columns. So number of columns is equal to 3. And we will say that the order of the matrix is equal to 3 by 3, or 3 cross 3. Is that clear, everyone? I hope the concept is clear. Now let's look into the next question. I really want you to try it on your own. What is the number of rows present here? Yes, give it a try, friends. Look at it. Yes, many of you got it correct. All of you got it correct. It is going to be 1 and 2. It is going to be 2 rows. So you have the number of rows to be equal to 2. And let's look at the number of columns. Number of columns is going to be 1, 2, and 3. So the number of columns is going to be 3. So that means that the order of the matrix is going to be what? It is going to be 2 by 3, because it is m by n. So you can see that this is how you represent the concept of order of a matrix. So order of a matrix gives you an idea about the number of rows and number of columns in a matrix, and it is represented by m cross n, or m by n. Is that idea clear regarding order of the matrix? I really hope so. So if this concept is clear, now we will move on to the next concept of this chapter. So before going to the next topic, I really feel that it will be nice if we could actually solve a problem, right? So let's read the question. This is a question directly taken from our NCERT textbook. Let's read the question. If a matrix has 8 elements, alright, so that means that the matrix has how many elements? 8 elements. What are the possible orders that it can have? What are the possible orders? So it is not clear that what is the order of a matrix, but we are given that it has 8 elements. So, but this is something that we never discussed, right? We never discussed about the number of elements and how it is connected to the order. We did not actually do that, but I think it is a simple logic. For that, I think I'll make you think of that itself. Say you look at this. How many elements does this particular matrix have? So it is going to have 1, 2, 3, 4, 5 and 6. So it has 6 elements. And what is the order of the matrix? It is going to be 3 by 2. Remember, 6 elements and 3 by 2 matrix. Keep that in one corner of your mind and we'll go on to the next one. How many elements does this have? It is going to be 1 element, 2 plus I, 2, 3, 4, 5, 6, 7, 8 and 9. That means that it has how many elements? 9 elements. What was the order of the matrix? 3 by 3. Keep it in mind, connect it to this one. I hope you got the answer right now, right? Now what will be the number of elements here? Look at the order. It is going to be 2 by 3 matrix. So it looks like a 3 by 3, right? I'll just write it as 2 by 3 itself. So it looks like so if it is a 2 by 3 matrix, how many elements should this have? Look at it and say the answer and check whether that answer is correct. Did you actually end up getting the answer to be 6? If so, you got the idea. So what is the idea? Think about it. Yes, very good, excellent. The idea is that you just multiply these two numbers, you end up getting the order. So that means that if you prime factorize this number 8, you can write down all the possible answers, right? So let's prime factorize the number 8. So I'm doing it. So it is going to give me 8 is going to give me 2, 4, 2, 2, 2 and 1. So that means that my 8 can be written as 1 into 2 into 2 into 2. Now we have to write down all the different possible answers of 8. For that, I'm going to do it. So first I'm going to take one element as 1. So that is going to give me, the possibility is that it is going to be 1 into 8. The possibility that it is going to be 1 into 8. Is that clear, dear friends? It is going to be 1 into 8. Now I'm going to take the first 2 elements. Now that is going to yield me, this is going to give me 2 and this is going to give me 4. So that means that it is going to give me 2 into 4. It is going to give me 2 into 4. Now let's take the first 3 elements together. So if I take the first 3 elements together, what is it I'm going to get? I'm going to get this to be 4 and this to be 2. So what is that going to be? It is going to be 4 by 2. Now the last case is going to be, I'm going to take all these things together. That means that I got 1 into 8. Now what I'm going to do is I'm going to take the opposite of that one, that is going to be 8 into 1. So that means that there are 4 different possible orders for this matrix in which it is going to have 8 elements. Now what is going to mean, what do you mean by 1 by 8? Say when I say that order of a matrix is 1 by 8, what does that mean? It means that the number of rows is equal to 1 and the number of columns is equal to 8. It has 1 row and 8 columns. Similarly, what does this mean? It means that it has 2 rows and how many columns? 4 columns. And what does this mean? It means that it has 4 rows and it has 2 columns, and in this case it means that it has 8 rows but it has only 1 single column. So that is the idea, and you got this question clear, I hope. How do you actually identify the number of possible elements in a matrix, and you can how it is related to the order of a matrix. So I hope this concept is clear from this question, right? So the important takeaway from this question is the total number of elements in a matrix is given by multiplying the numbers of columns and rows. Okay, if you multiply the number of rows and columns, you end up getting the number of elements in the matrix. And another important takeaway is that the number of elements, all the possible orders, if you want to find all the possible orders, you have to go for the concept of prime factorization of the total number of elements in the matrix. Okay, you have to go for the concept of prime factorization of the total number of elements in the matrix. So I hope the concept is clear. So shall we move on to the next concept? I really hope that this concept is clear. We are going on to the next concept, which is going to give me the different types of matrices. So let's move on to the next topic, types of matrices. So next we are looking into the different types of matrices. So let's start with the first one, which is called as column matrix. Now what do you mean by column matrix? Column matrix means that the matrix having only one column. That means that the matrix will have only one column, and what will be the number of COLOUMN? That means that it will have only one single column. Now what will be the number of rows? It can have any number of rows. The number of rows is not an issue. It is going to, the condition is that it should have only one single column. Say for instance, if I am going to give you a standardized example, it will look something like this. If I am having a matrix like this means that the matrix is having only one single column and it is having 1, 2 and 3 rows. Now let's try to write the order of this matrix. When I am trying to write the order of the matrix, we know that the order of the matrix should be written of the form m by n, where m is the number of rows and n is the number of columns. So you can see this is going to be 1, 2 and 3. So that means that how many rows does it have? It has 3 rows. And how many columns does it have? It has only one column. So the order of the matrix is going to be 3 by 1. Now let's take another example. So if I'm taking another example, say B, it is going to look something like this: 1, 2, 3, 4. Now what is going to be the number of rows in this particular case? The number of rows is going to be 1, 2, 3 and 4. That means that the number of rows is going to be 4. And what is going to be the number of columns in this case? The number of columns is going to be 1, because it is a column matrix. So basically we can say that the order of a column matrix will be of the form m cross 1, where m is the number of rows and 1 is the number of columns. Is that idea clear to you? So basically we can say that the order of a column matrix will be equal to m cross 1. Now we have the next one, which is called as row matrix. Now what do you think is going to be row matrix? Yes, it is going to be, I think, very simple, because you can directly connect it to what? Directly connected to what you have already studied for column matrix. So what does it mean? It will have only one row. That means that it can have any number of columns, but it should have only one row. Say for instance, if I'm taking an example, say A is going to be 1, 2, 3, 4, 5. Now let's see how many rows does it have. It has only one single row. How many columns does it have? 1, 2, 3, 4 and 5. Is that idea clear to you? 1, 2, 3, it is going to have one row. Then how many columns? 1, 2, 3, 4 and 5. So what is going to be the order of the matrix? It is going to be 1 by 5 matrix. Say for instance, it has another matrix. If I'm going to take another matrix, say B, I'm going to take another matrix, say B. This is invisible for you a little bit, right? Yes, now it is clear. I'm going to take another matrix B. Say for instance, it is going to be A, B and C. Now let's see what is going to be the order of this matrix. You can see the number of rows is going to be 1. It has only one row. And the number of columns is going to be 1, 2 and 3. So what is going to be it? It is going to be 1 by 3 matrix. So in general, what can we say? We can say that a row matrix will have of the order 1 by n matrix, where n is going to be the number of columns. N is going to be the number of columns, and here you can say m is going to be the number of rows. Here you can say that m is going to be the number of rows. Is that idea clear to you? I hope the concept of row matrix and column matrix is clear. So once it is clear, let's go for the concept of square matrix. Yes, what is going to be a square matrix? A square matrix is going to be a matrix in which the number of rows is equal to number of columns. Please wait. Yes, the condition is that the number of rows must be equal to the number of columns. What does that mean? It means that the number of rows, if the number of rows happens to be 3, then the number of columns should also be equal to 3. If the number of rows is equal to 2, then the number of columns should also be equal to 2. If the number of rows is equal to 4, then the number of columns should also equal to 4. Is that idea overall clear to you? That is the idea. That means that you can see that you can basically see that it will be of the order, so it will look something like this. It will be looking something like m cross m. So what does that mean? M cross m means if m happens to be the number of rows, then m should also be the number of columns. Say for instance, we can give some examples here. So if I'm taking an example, A is equal to 1, 2, 3, 4. So what is going to be the number of rows here? You can say 1 and 2 is the number of rows, 1 and 2 is the number of columns. So you can say this is going to be a matrix of the order 2 by 2. So you can see the number of rows and number of columns are equal. Now I can take another example. Say I'm taking B, in which it is going to be of the form, say, let me take letters this time. So A, B, C, D, E, F and G, H and I. So you can have how many elements? You have how many rows it is going to be? 1, 2 and 3 rows. It will have 1, 2 and 3 columns. So that means that it is of the size 3 by 3. So you can see again that the number of rows and number of columns are equal in this case also. So we can basically say that the number of rows and number of columns are equal. So it is taking the form m cross m. So that is the idea of square matrix. So I hope the concept of square matrix is also very much clear to you. Now let's look at the concept of diagonal matrix. For understanding the concept of diagonal matrix, you need to know the concept of diagonal elements. So what is a diagonal element? So the diagonal element is, the first thing that you need to know is regarding the concept of diagonal element. So diagonal element is called as Aij, where I must be equal to j. Now this is a new concept for you. What is this I and what is this j? Now for this we need to get introduced to a very simple concept of identifying the position of an element in a matrix. That is something that we have not done till now, but now we will be actually doing it, because we will mix it together. Actually this was the next topic, but we will mix it together. Consider that this matrix is of the order m cross n. Okay, this is a generalized form and this is a real form which is going to be taking as A23. So that means that m cross n means it has how many rows? M rows and n columns. What does this 2 by 3 means? It has 2 rows and 3 columns. That is the idea. So here you can say this is going to be A, B, C and D, E and F. So you can see how many rows? 2 rows and how many columns? 1, 2 and 3. Here you don't know the value of m and n, so let it be like that. So here you can see this is element, this particular element, you can see this lies on the first row and first column. This, as I said, this element will be lying in the first row and the second column. This is lying on the first row and third column. Now I'll just repeat it again. This position or this element is lying on the first row and first column. You can see that this is at the intersection of first row and first column. This element is lying in the intersection of first row and second column. Here again you can see this is lying in the first row and third column. So you can see again this is going to be on the second row and the second column. Now this is going to be in the second row and second column. This is going to be on the second row and third column. Did I actually make a mistake here? I think I did. That is the second row and first column. It is going to be second row and first column. So I'll just write it in a different way altogether. I'm going to write it like this. I'm going to write this as A11. Now what does A11 means? A11 means it is the element in the first row and first column. Now what do you mean by A12? What if I write A12 here? A12 means it is the first element and it is in the first row and the second column. That means that if I write Aij, if I write in general Aij, this means that it is in the ith row and jth column. It is in the ith row and jth column. I think there is some issue when I write it there. I'll write it here. So when I write Aij, it means it is in the ith row and it is in the jth column. Is that idea clear to you? Alright, so in this case you can see A11 means it is in the first row and first column. A12 means it is going to be in the first row and the second column. Now when I write A13, what does that mean? It means that it is in the first row and the third column. Now this is going to be second row and first column. This is going to be second row and second column. This is going to be second row and third column. So that is going to be it. So this is going to be an 2 by 3. So if I write in general A45, what does that mean? It means that it is in the fourth row and the fifth column. Is that idea clear to you? It means when I write A45, it means that it is in the fourth row and the fifth column. That is the idea of when I write Aij. That means that it is in the ith row and jth column. Is that idea clear to you? I hope that logic is clear. Now what do you mean by diagonal element is that you take an element Aij and I should be equal to j. It should means that Aij means I must be equal to j. That is the idea of diagonal element. That is the idea of diagonal. That is how you define the concept of diagonal elements. So in a diagonal element means, so that means that the different possible values are I is equal to j is equal to 1. That means that it is going to be A11. The next is possibility is that A22. Next we have A33, etc. It goes on. Like it can be A11, it can be A22, it can be A33, A44, A55. It can be anything like that. I hope that logic is clear. clear. So that is the idea of diagonal element altogether. So once you get the idea of diagonal element, now we will look into the concept of diagonal matrix altogether, because diagonal element is easy to understand. Understanding diagonal matrix is a little bit different. So once you get the idea of diagonal element, now we'll look to the concept of diagonal matrix. And diagonal matrix should always be a square matrix. That is the first condition. What is the condition? It should always be a square matrix. That means that the number of rows and number of columns should be same for a diagonal matrix. And the second condition is that every element other than diagonal elements, every elements other than diagonal elements must be equal to 0. Every element other than diagonal elements must be equal to 0. A very interesting condition, right? It's a very interesting condition, and the condition says that every element other than diagonal element must be equal to 0. If we look for some kind of an example, it will look something like this. If I take a matrix like this, say A is equal to 1, 2, 3, and I actually make all other elements to be 0, this could be an example of diagonal matrix. And you can see that all the diagonal elements, this is going to be A11, this is going to be A22, and this is going to be A33. How did I understand that? This is going to be first row and first column. First row and first column. Now this is going to be second row and second column. This is going to be third row and third column. And you can see it looks like a diagonal of the rectangle also. Is that logic clear? It is going to be the diagonal of the rectangle also. So that is the idea. And all these elements can be any numbers, but if the remaining elements happen to be 0, then you call this matrix as a diagonal matrix. Is that idea clear to you? For understanding the concept of diagonal matrix, we had to understand multiple concepts in this concept, right? So the first thing that we actually understood was regarding what do you mean by a diagonal element. Diagonal element means Aij is equal Aij where I is equal to j. Aij where I becomes equal to j, and the examples are A11, A22, and A33. And you can see this, it looks like a diagonal also. And please understand that this never forms a diagonal. Why? Because this element is going to be first row and third column. That means that I and j will not be equal. So don't consider a diagonal like this. The diagonals of a matrix is always in this form. Okay, it is always in this particular form. I hope that logic is clear to you. So every element, if other than diagonal element become equal to 0, then it is called as a diagonal matrix. Alright, I hope the logic is clear. Now let's look into the concept of scalar matrix, which is going to be the next type of matrix, which is extremely easy. Why? Because if scalar matrix is actually a type of diagonal matrix. It is a type of diagonal matrix. It is a special case of diagonal matrix. And what is a special case? It says that every diagonal element must be equal. Every diagonal element must be equal. A very unique condition, right? So this is actually what you can say, that this is actually a type of, it is a type of scalar diagonal matrix. Is going to be a special case of diagonal matrix, and we already know what is a diagonal matrix. What is it? It is just that it is going to be a special case of square matrix in which all the elements other than diagonal elements are equal to 0. The specialty is that you can see all these elements need not be equal in diagonal matrix, but if all of them become equal, then you call it as a scalar matrix. So that means if I take an example, for instance, so it should look something like this: root 3 0 0 0 root 3 0 and 0 0 root 3. So you can see that all these elements are equal, right? So you can basically see that all these elements, that is the diagonal elements, are becoming equal. If these diagonal elements are equal, then it is called as a scalar matrix. I hope the logic is clear, right? Fine, very good. Now let's look into the concept of identity matrix. Now that is even more easier. It is again a special case of diagonal matrix. This is going to be a special case of diagonal matrix. Or you can also say that this is also a special case of scalar matrix also, because the condition here says the diagonal elements must be equal to 1. The diagonal elements must be equal to 1. If all the diagonal elements of this matrix, of a square matrix, becomes equal to 1, then you call that matrix as identity matrix. That means if I am taking an example, say C, it will look something like this: 0 1 1 1 1 0 and 0 0 1. So this is the logic of a scalar matrix. So you can, identity matrix. Identity matrix will have all the elements to be equal to 1. Here you can see all the elements are equal. Here you can see all the elements are not equal, but all the surrounding ones are equal to 0. So I hope the logic is very much clear regarding the different types of matrices. It's extremely important to understand the different types of matrices, because you will be learning a lot of properties of the different types of matrices in the upcoming classes. So I hope the concept is clear. So once this concept is clear, now we will move on to the next topic, which is called as equality of matrices. That means that when can we say that two matrices are equal? Now let's go and see that. For two matrices to be called as equal matrices, all the elements of the matrix should be equal. Now let's see that. Say that means that what is the condition? For two matrices to be called as equal matrices, what is the condition? All the elements, I'm not talking about a single element, but all the elements of both the matrices, all the elements, you cannot say all the elements, you should say all the corresponding elements. That is very important. All the corresponding elements of both the matrices should be equal. All the corresponding elements of both the matrices should be equal. Now let's see how that translates into some examples, right? We just understood the definition of the whole thing. Now we'll just read it once again. For two matrices to be called as equal matrices, all the corresponding elements. Now we need to understand what is the meaning of corresponding elements. Now we know that for two matrices to be equal, when we say the two corresponding elements means, that means if I'm taking an element here and another element in another matrix, you can see that this element will have A11, A12, etc. to A1m. If the order of the matrix is say m by n, I'll just take another form. If order of the matrix say that is equal to m by n, we will say that the first element is going to be A11, the second element is going to be A12, and etc. it goes. Similarly, you will have A21. Similarly, it will go up to how much? It will go up to AM1, and it will go on and it ends at AMN. So this is going to be how the matrix will actually look like. Actually, this is the problem with writing matrix. First, when you draw the size of the matrix, it won't be actually correct. So we'll have to edit it all the time. So there is going to be m by n matrix means it will go on up to A1n. You can say it will go up to A1n. So this is how the matrix will look like. So if two matrices have to be equal, this matrix will have A11. That means it is corresponding to the first row and first column. So if I take another matrix, say you have to, for equality you need two matrices, right? So if I'm taking the second matrix and I'm calling it as a B, then the elements will be called as a B11, B12, etc. up to, it will go up to B1n. Similarly, it will go like this up to B into mn, and again this will go like B21, etc. up to Bm1. So this is going to be the second matrix. I have two matrices I have taken into picture, which is going to be A and B, and both of them will be of the size of m cross n. So you can see this element B11 and A11 should be equal because they are corresponding elements. What do you mean by corresponding elements? First row and first column. Now if we go into this one, these two elements are actually equal. Why do we say these two elements are equal? Because it is in the first row and second column. Now if we go here, you can see these two elements are corresponding elements. Why do we say these two elements as corresponding elements? Because this is the second row and second column. Similarly, it goes on and you can say these two elements are equal. Why do we say that these two elements are equal? Because it is the first row and the nth column. And similarly, these two elements will also be equal. Why do you say that these two elements are also equal? These two elements are also equal because it is in the mth row and nth column. So I hope the logic of corresponding elements should be equal is clear now. And when you say something like that, there is one more condition that is automatically coming into picture, and that is the order of the matrices should also be same. The order of the matrices should also be same. If the order is not different, if the order is different, then the number of elements will also be different. So the two conditions for equality of matrices could be actually, we can actually combine it together, right? Let me actually combine it together into a single space. Yes, I think I'll need some space here. If we need two matrices to be equal, we can say the corresponding elements should be equal, and we can also say order of both matrices should be same. Order of both matrices should be same. Order of two matrices should be same. These are the two conditions that we can say that is important for equality of matrices. Alright, I hope the logic is clear regarding the concept of equality of matrices. And now let's look into a question that is there in our NCERT textbook. Now you can again see that they are asking about us to find the values of A, B, C, X, Y and Z, and there is an equality sign between these two matrices. You can see this is one matrix, this is another matrix, and there is an equality sign in between. That means that these two matrices are equal, and we have to find the answer to these variables. The first thing we have to check that whether if two matrices are equal, you have to check the order of these matrices. Now you can see what is the order. 1, 2, 3, 3 rows, 1, 2, 3, 3 columns. So the order of this matrix happens to be 3 by 3. Okay, acceptable. What is going to be the order of this matrix? It is going to be 1, 2, 3, 3 rows, 1, 2, 3, 3 columns. So this is again equal to 3 by 3. So we can say again this is acceptable. We have taken two matrices of the same order. So our condition number 1 is okay. Okay, so it is satisfied. Now we can say since these two matrices are equal, we can say both these matrices are, all these elements are, corresponding elements will be equal. That means that this element and this element will be equal. From this you can say that x plus 3 is equal to 0, from which I will be able to say x is equal to minus 3. Is that clear, dear friends? From that first element itself, we were able to identify the value of variable. Now let's look into the second element, and the second element is z plus 4 is equal to 6. Are you able to understand how I write it? Because this is the corresponding two elements. So in this next equation, I am going to write z plus 4 is equal to 6. This implies z is equal to 2. So you got the value of the variable z, which is equal to 2. Clear, friends? So shall we move on to the next question? Yes, the next question is going to be 2y minus 7 is equal to 3y minus 2. So let's write it. 2y minus 7 is equal to 2y minus 7 is equal to 3y minus 2. So from this we can say y is equal to minus 5. You can say y is equal to minus 5. How? I am bringing 2y to the other side, is going to be 3y minus 2y, and you are taking minus 2 to this side, so it is going to be plus 2 minus 7, so it is going to yield me minus 7. So what is going to be the value of y for me? The value of y is going to be equal to minus 5. Okay, I think I am ruining your data. Yes, I have moved to the other side now, right? Let's look into the next question, and the next question is going to be, yes, a, right? We have to find the value of a. Now a minus 1 is equal to minus 3. You can see that this element is fine. It has no variables. That is minus 6 is equal to minus 6. So that is fine. But here again you can find a minus 1 is equal to minus 3. So that is going to be my next equation, which is a minus 1 is equal to minus 3. Now you will take the minus 1 to the other side. You will directly get the value of a to be equal to minus 2. Now that seems to be the answer for a is equal to minus 2. Is that clear, dear friends? We got the answer for value a. Now let's look at the next one. Next one is going to be 0 is equal to 2c plus 2. Again we need a calculation. So 0 is equal to 2c plus 2. So the next equation is 2c plus 2 is equal to 0. So that means that 2c is equal to minus 2, or say c is equal to minus 1. So that is going to be my next equation, that is c is equal to minus 1. Now let's look at the next one, which is going to be b minus 3 is equal to 2b plus 4. Again it is going to be a lengthy equation. 2b plus 4 is equal to b minus 3. Now what do? You bring b to this side and you will bring 4 to the other side. So that means it is going to be 2b minus b is equal to minus 4 minus 3. All you say b is equal to minus 7. We will say b is equal to minus 7. So that is going to be my next variable solved. Now do we have any more variables? No, because minus 21 and minus 21 has no variables. 0 and 0 has no variables. We were asked to find the values of, I think we found out the values of all the variables now, right? We found out the value of x, yes. We found the value of y, yes. We found out the value of z, yes. We found out the value of a, yes. We found out the value of b, Let me take it. Yes, we found out the value of B and we also found out the value of C. I have color coded everything right now, right? So I hope the logic is clear regarding the concept of equality of matrices. So equality of matrices is relatively a very simple topic, but there could be many questions that could be asked from this in this particular manner, in which two varied matrices could be given and the equality of these two matrices will be in the picture. All right. So I hope the logic is clear. Now we will be moving on to the next topic. We have really understood the concept of equality. Now we'll be moving on to the concept of operations on matrices, in which we'll be studying about the concepts of addition, subtraction and multiplication of matrices. Of course, there is no concept of division because matrices cannot be divided as such. So that is the logic. Now we'll be moving on to operations, which is going to give us addition and subtraction first. So let's move on to operations. Operation on matrices include the first topic that we are going to study in operation of matrices is the addition of matrices. I think I just lost my mic. Yes, so the operation of matrices that we are going to study in the first one is addition of matrices, and let's see what is the condition for addition of matrices. So for addition of two matrices, the fundamental condition that we are supposed to satisfy is the fact that both of them should be of same order. That means if we have to add two matrices, or if you want, the same concept actually applies for subtraction also. This concept is applicable for addition as well as subtraction, and the condition is that the matrices should be of same order. A very, very important condition that needs to be satisfied. Say if you have a matrix of the order 2 by 3 and you have another matrix of order 3 by 4, then you cannot add these elements. Alright, so that is the idea, and for this, in addition as well as subtraction, the rule is actually pretty simple. Say for instance, if you have a matrix, say A is equal to 1, 2, 3, 4, 5, 6, and the order of this matrix, let's write down the order of this matrix. It is going to be 1, 2, 2 and 3, right? So the order is going to be 2 by 3 matrix, plus if you want another matrix, say I'm adding another matrix to it, and that matrix happens to be B, which is equal to -1, 4, 0, 2, 5 and 8. So again you can see that this matrix is also of the order 2 by 3. This matrix is also of the order 2 by 3, and if you want to find the value of A plus B, what is it that you are going to get? The first thing that you have to check is the order of the two matrices. You have to check that whether the order of these matrices are going to be same or different. That is the first thing that we have to check, and we can see that the order of these two matrices are same. Order of these two matrices are same. This is going to be a 2 by 3 matrix. This is also going to be a 2 by 3 matrix. So I hope the order is going to be same now. Once the order is same, what we have to do in order to add them is you have to add the corresponding elements. When we were thinking about the equality, when we were talking about the concept of equality, we talked about the corresponding elements being equal. In this case, what you have to understand is the corresponding elements should be added. If you are going for an addition, the corresponding elements should be added. If you are going for subtraction, the corresponding elements should be subtracted. So in this case, you can see these two are going to be my corresponding elements. So I am going to mark it in the same color. These two elements are going to be my corresponding elements, and what is going to come here in A plus B? It should come at the same position. So 1 plus -1 is going to be equal to how much? It is going to be equal to 0. Very good. So I hope the concept is very much clear for that one. Now let's look into the next two corresponding elements. 2 and 4 happens to be corresponding elements in the position of first row and second column. First row and second column. So what is going to be the sum of A plus B? That is going to be 2 plus 4 is going to be equal to 6. So that is going to be my answer to the second element. Now let's go for the third element, and you can see that these two elements are 5 and 0. These two elements are 5 and 0. This is going to be in the position of first row and third column. First row and third column. So 5 plus 0 is going to be equal to how much? It is going also to be equal to 5. So now let's compare the third one. This is going to be this element, these two elements. As you can see, this is going to be in the position, which is going to be the position. Think of the position. It is going to be in the first row and the it is going to be in the first column and the second row. So it is second row and first column. So again here also second row and first column. So this is going to be the position. You will just get 3 plus 2, which is equal to 5. So that is again you got the answer. Now let's look at the next position, which is going to be, this is the position, and which is going to be what? what? Second row and second column. Again, second row and second column. What is going to be the sum of these two elements, which is going to be equal to 9. Again, that is an impressive way of adding it. So this is going to be 6 and 8, which is going to be my final one. 6 and 8, which is going to be in the position second row and third column. Second row and third column. What is going to be the sum of 6 and 8? 6 and 8 is going to yield me 14. So I hope you got the answers very clearly regarding which is going to be added, and the concept of corresponding elements, I hope it is clear. I took a lot of time in explaining the concept of corresponding elements, and I took a lot of effort into bringing in that color coding concept. Look into it and try to understand the idea. So I hope the concept is very much clear regarding the addition. Now let's see what will happen if the same question was asked as subtraction of matrices. We were asked to find the value of A plus B. Now what if the same question was asked in such a way so that it was asked us to find the value of A minus B? Let's try to find out the value of A minus B, shall we? Yes, we shall. Yes, that's the answer that is supposed to give me. So let's try it. A minus B, right? So again, we are going to take the corresponding element. So 1 minus of minus 1. Now what is going to be 1 minus of minus 1? Minus of minus will become plus, so it is going to be equal to 2. Again, I hope the concept of corresponding elements are going to be same. Now let's look at the next one. It is going to be, this is going to be 2 and 4. So 2 minus 4 is going to be equal to minus 2. So that is going to be equal to minus 2. Is it clear, dear friends? Let's look into the next one, which is going to be 5 and 0. What is going to be 5 minus 0? 5 minus 0 is going to be again equal to 5. So you got that answer very clearly. Now let's look into the next question, which is going to be 3 and 2. What is going to be 3 minus 2? The 3 minus 2 answer is going to be equal to 1. The 3 minus 2 answer is going to be equal to 1. Now let's look at the next question, which is going to be 4 minus 5. 4 plus 5 was 9. Then 4 minus 5 is going to be equal to minus 1. Again, you got the answer. Now let's look at the last position, and the last position is going to give me 6 minus 8, which is going to be equal to minus 2. Please wait a moment. It is going to be minus 2. Yes, we got the matrix. We got the matrix. Yes, you got the answer to be equal to minus 2. Yes, so that is the answer of addition as well as subtraction of elements. So I really hope the concept of addition and subtraction of elements is very much clear to you. We discussed the concept and we discussed one question. Of course, it is nice if we could discuss more questions, right? So let's discuss one more question. So let's look at the question that is given to you, and it is a question from the NCERT textbook itself. So you can see that you are having two matrices, matrix A and matrix B. We are asked to find the value of A plus B. Now the first thing that we have to check is whether the order of these two matrices are equal. That is the first thing that we have to check. For that, let's check the number of rows. It is going to be 2. What is the number of columns? It is going to be 3. So what is going to be the order of this matrix? 2 by 3. Acceptable, right? Right, let's look at the next one. It is going to be 1, 2 and 3. 3 columns, 1 and 2 rows. So your answer is going to be again 2 by 3. Now we have to compare these two. This is going to be 2 by 3. This is going to be 2 by 3. So we can say that matrix A and matrix B can be added, and A plus B has an answer. If this was a 3 by 3 matrix, then we would say that A plus B is not a possible answer. That means that A plus B cannot be found out. Is that logic clear? When can we add two matrices and when can we not add two matrices? Alright, fine. Now in this case there is no confusion, so let's go and find out the value of A plus B. So we'll be directly writing the answer. I'll not be using any kind of color codes here. So first element is going to be root 3 plus 2. That is going to be my first element. My second element is going to be 1 plus root 5. That is going to be my second element. This is going to be which one? The second element, in the sense it is going to be the element in the first row and second column. Now let's look for the first row and the third column. It is going to be it is going to be minus 1 and 1. The sum is going to be equal to 0. Now let's look for the second row and the first column. It is going to be 2 and minus 2. The answer is going to be, sum is going to be equal to 0. Now let's look for the next one. It is going to be the second column and second row. You can see both are 3. 3 and 3. The sum of 3 and 3 is going to be equal to 6. Now the last one, it is going to be your second row and third column. Second row and third column, the elements happens to be 0 and 1 by 2. So your answer is going to be 1 by 2. So that is the answer for A plus B. So the addition of matrices is extremely simple, right? We just discussed this matrix. So we have discussed the concept of operations on matrices, and we discussed addition as well as subtraction of matrices, and we did two questions, right? We did one question, 2 question and 3 questions. So we have discussed the 3 questions from regarding operations or matrices, addition and subtraction. Now the next operation that we are going to study is regarding the scalar multiplication, that is multiplication of a vector by a scalar. Now let's look into that topic, multiplication of a vector by a scalar. So in multiplication of a vector by a scalar, it's important that we read this definition. Now I'm just bringing you the definition from our NCERT textbook, but it is very unconventional, right? Because generally we don't have the habit of studying the theory in mathematics, but it's very important that you read these sentences so that you will be able to understand, or you will have that ability to read a sentence and understand it. That is extremely important, especially in terms of mathematics. So let's read the sentence. I'm sure that it will be easy for you to understand it. Just give it a simple try. Just try it, you will easily understand it. It is just that most of the students generally don't take the effort, or they just don't know that they have to do it. That's it. But right now you have that knowledge that you have to read these sentences, so please do it. We'll do it together. It's very easy. So let's do it. In general, we may define multiplication of a matrix by a scalar as follows. If A matrix ij, which is of the size m cross n, so that means that what is the size of my matrix? My size of the matrix happens to be m cross n. I hope you are all able to see it, right? So if you're not able to see it, I think I'll just make it a little bit larger for you, right? I think it will be better if I can make it a little bit larger. Yes. And now you can see you are having a matrix A, and the elements are generally called as aij, and the size of the matrix is m by n. So what is going to be the elements, the total number of elements is going to be multiplied by the product of m and n. Now it is a matrix, and k is the scalar with which I am going to multiply. Now when I am calling, say, scalar, what do you mean by scalar? Scalar just means it is a number. That means that if I am having a matrix, say A, and I will be multiplying this matrix by 4, or I will be multiplying this by -2, or 1 by 3, root 3. So it does not matter whether that scalar happens to be a natural number, a negative number, a fraction, an irrational number. It doesn't matter. Whatever may be that scalar, you multiply that matrix with that scalar. So that is why we are calling it as a K. So in general, K is going to be called as scalar, and scalar will be a number. It is going to be a real number. What do you say? It is going to be a real number. It can also be variables. We should understand that it can also be real number, it can also be variables, it can also be functions. All these possibilities are there. Alright? So you have all. So when I say K into A, this K into A is actually forming a new matrix. K into A is actually forming a new matrix which is obtained by multiplying each element of A by a scalar K. That means that we have to multiply, obtained by multiplying each element of A. That means that you should not multiply a single element. Instead, you have to multiply the whole elements of A with this scalar K. Say for instance, I will give you a small example as such. So when we are taking an example, I am going to take an example of matrix A to be equal to -1, 0, 2, 4. So that is going to be my matrix, -1, 0 and 2, 4. Right now I am going to multiply that matrix with -2. Now how should I multiply this -2? That means the K happens to be -2. This K happens to be -2 in this case. So K into A is going to be -2 into A. Now what is it that we are supposed to do? We have to multiply each element of A by the scalar. So which are the elements? -1 is my element, 0 is my element, 2 is my element, 4 is my element. So I have to multiply each and every element with the scalar K. So in this case, since it is -2, I have to multiply -1 and -2. What do I get when I multiply -1 and -2? I'll get the answer to be equal to 2. Clear? Now what do I get when I multiply 0 and -2? What is it that I'll get? I'll end up getting the value to be equal to 0. Now what do I get when I multiply 2 and -2? What is it that I'll get? I'll get the answer to be -4. What is it that I'll get when I multiply 4 and -2? I'll end up getting the answer to be equal to -8. Now this is going to be the scalar product. Is that clear? Is that clear, dear friends? It's extremely simple, right? You just have to multiply every element. That's it. Nothing more that we have to do. Alright? So let's take one more case. If I'm going to multiply this by, say, 1 by 3 into A, what is going to be my answer? Let's try that also. We have tried with 2. Let's try with a fraction. So what is going to be my answer? Let's see what is going to be the answer that I will get. So I have to multiply -1 and 1 by 3. So what is going to be my answer? My answer is going to be -1 by 3. Again, I have to multiply 0 and 1 by 3. So what is going to be my answer? My answer is going to be 0. Next, I have to multiply 2 and 1 by 3. My answer is going to be 2 by 3. Next I have to multiply 4 and 1 by 3. So my answer is going to be how much? It is going to be 4 by 3. So this is how you will get the answer for scalar multiplication. I hope that logic is very much clear, and also have this habit of reading this sentence and trying to understand what this says. It is extremely important that you read the sentence and understand what it says, because that is how you develop this habit of, when you see something like this, it should not feel really alienated to you. So please ensure that you read this sentence. Alright, so once we understood the concept of multiplication of a scalar and this particular concepts, we need to now understand and look into the properties of multiplication by scalar. But before looking into the properties, shall we actually do a problem combining all these things together? Yes, I think we shall. That means that we are going to combine the concept of addition and subtraction of matrices plus the concept of multiplication of vector by a scalar. I think we'll do a problem with that. Then we will go into the concept of properties of multiplication. Alright, let's do it. So let's read the problem here. The problem says, it is an example question from NCERT. So if A is equal to, we are given a matrix, and B is equal to another matrix, and we are supposed to find 2A minus B. Now 2A minus B means you have to multiply A with the scalar 2, then you have to subtract B from it. So that is the idea of 2A minus B. So let's try to do it. So the first thing that we have to identify is check whether these matrices are of same order. So let me check it. This is going to be of the order 2 by 3, acceptable. This is going to be of the order 2 by 3, again acceptable. So both are acceptable. Now let's find out 2A first. So I'll not be actually writing all the steps for you, because you can do it on your own. So 1, 2, 3 means you have to multiply. If you have to multiply with 2 means you have to multiply each element by 2. So that means that 1 will become 2, 2 will become 4, and 3 will become 6. So it is going to be 2, 4 and 6. Now 2 will become 4, 3 will become 6, and 1 will become 2. So this is going to be 4, 6 and 2. So that is going to be the value of 2A for me. Now B of course is ready made, and that is going to be 3 minus 1 3 minus 1 0 and 2. Now let's write down the value of 2A minus B, which is going to be equal to the difference of these two. So let me first do, it is going to be 2 minus 3. What is going to be the answer? That is going to be equal to minus 1, because this is my first row and first column, corresponding elements. Now let's look for the next corresponding element, that is going to be 4 and minus 1. So the difference of 4 and minus 1 is going to be 5. 4 minus of minus 1 is going to be 4 plus 1 is 5. Now again this is going to be 6 and 3. So this is going to be 6 minus 3, which is equal to 3. Now the last one is going to be 4. The next one is going to be your first row and the second column. It is going to be the first column and second row, right? Yes, it is going to be the first column and second row. So it is going to be 4 minus of minus 1 is going to be equal to 5. The next is going to be 6 minus 0 is going to be 6. And the last one is going to be 2 minus 2, which is equal to 0. So you got the answer of 2A minus B to be equal to a completely new matrix, having this as the answer. So I hope the logic of multiplication of matrix is completely clear to you. Multiplication of a matrix by a scalar is clear. Also the concept of addition and subtraction is also clear. Now we shall be moving on to the concept of properties of multiplication. You need to actually see the properties of two things. We need to see the properties of addition and subtraction, as well as we have to see the properties of multiplication of a vector by a scalar. So these two things are going to be taught simultaneously. So let's look into both the properties. So let's look into the properties of matrix addition. So matrix addition, the first property that we need to learn is about the concept of commutative property. So that is the concept of commutative property. Now let's see what is the idea of commutative property. Commutative property means you have a matrix A and you add a matrix B to it. That means that you are going to get A plus B, and the value of A plus B must be same as B plus A. That is the idea of commutative property. So this will be basically applicable for matrix addition. Note that it will not be applicable for matrix subtraction, because we know that 4 minus 3 is not equal to 3 minus 4. You know, right? Because this answer is 1 and this answer is minus 1. So that means it is not going to be the same. So for both of them to be same, we have to ensure that we have A plus B and B plus A. Both are going to be equal in case of addition, but not in case of subtraction. So this is the idea of commutative property. Is that idea clear to you? Now let's look into the next property, which is called as associative property. Let's look into the next property, which is called as associative property. Now associative property is a little bit different from this one, and the property says this is going to be A plus B plus C is equal to A plus B plus C. That means that you have a matrix say B plus C, you have a matrix B and you have a matrix C, you add B plus C and then you add A to it. Then this is going to give me same result as you add A plus B and then add C to it. So this is exactly like addition of numbers itself. Say if you add the numbers, say for example 4 plus 2 plus 6, this is going to yield me 8 plus 4 which is equal to 12 is going to be same as 4 plus 2 plus 6, that is 6 plus 6 is also equal to 12. That means this is the same idea that we are actually bringing in. This is applicable for matrices also. For matrices also follow the same rule as that of addition in case of commutative and associative property. We should understand that it is not going to be exactly the same for addition. The properties of addition of numbers and addition of matrices are not going to be exactly the same, but most of the properties will align itself to it. Alright, so let's look into the next property, which is called as the concept of, this is not actually a property, we are looking into the next concept of additive identity. The concept of additive identity. That means that you need to have a matrix. You need to have a matrix. When I add a matrix to it, you should get the same value to it. Alright, so that means that it is exactly like the number 0. Say for instance, you add a 0 matrix to it. What is going to be this 0? The 0 is actually, or O is standing for 0 matrix. Now let's see what is going to be 0 matrix. A 0 matrix is the matrix having all the elements to be equal to 0. If all the elements of a matrix happens to be 0 and you add A to it, then what is going to be the result? You know that the result is going to be A itself. So that is the idea of additive identity. That means that if you add a particular matrix to a given matrix, then you yield the same matrix. This is similar for multiplicative identity also, right? Because say you have the number 1, that is going to be your multiplicative identity. If you multiply 4 and 1, you will get 4. If you multiply 10 and 1, you will get 10. That means that if you multiply a number by 1, you will end up getting the same number. When you add a number, if you add 0 to any number, you will get the same number itself. If you add 0 to 5, you will get 5. If you add 0 to minus 3, you get minus 3. If you add 0 to 10, you will get 10. That is the idea of additive identity, and that is the idea of 0 matrix. It's extremely important that you identify the idea of 0 matrix. 0 matrix is a matrix that we create so that we can create something called as an additive identity. Is that idea clear to everyone? I really hope so. Now let's reduce the size of the whole thing here so that we will be able to write it once again. That C is not included, right? Let's bring it here. Yes, now we have done it. Now let's look into the next concept, which is called as additive inverse. The next property is called as additive inverse. Now what do you mean by additive inverse? Additive inverse means you add a matrix to it and you should yield the value to be equal to 0. That is the idea of additive inverse, right? You add a number 4, you have a number 4 and you add something to it, you should get the value to be equal to 0. So again you can see that if you add a number to it, if you take a matrix, say for instance, I'll just explain that in detail. Say for instance, if you are having a matrix, say 2, 3, 4, 1, 2, 3, and you add a new matrix, say I'm going to add a new matrix, say X to it, you will end up getting O. O is going to be my 0 matrix. So what is going to be A? A is going to be 2, 3, 4, 1, 2, 3, plus you are going to have a matrix and you have no idea what that matrix is. So I'm going to name it as a X11, X12, X13. That is how I'll name it, right? Next is going to be X21, X22 and X23. I hope it is clear, right? Is equal to, what is it that you're supposed to do? You're supposed to write it to be 0, 0, 0, 0, 0, 0. So because all of them has to be of same order, right? All of them has to be of same order. Now let's see what is going to be the scenario. Now it is going to be, for actually finding out this additive inverse, what is it that you're supposed to do? You are supposed to take this to the other side. That is what we generally think. But in this case, you don't think like that. What you do is that you add a minus A to both sides. What do? You add a minus A to both the sides. You add a minus A here, you add a minus A here. So that means that when you add a minus A to both sides, what happens is, what do you mean by minus A? You multiply the matrix A with the scalar minus 1. You multiply the scalar matrix A with the scalar minus 1, and now you can see that the sum of these two will be equal to 0, because 2 will become minus 2, 3 will become minus 3, 4 will become minus 4, exactly like that. So minus A plus A is going to be equal to 0. So this equation altogether will become 0 plus x is equal to minus a, or you will get x is equal to minus a. So this is going to be my additive identity. This is going to be my additive identity. So that is the concept of, sorry, additive inverse. That is going to be my additive inverse. So what is going to be my additive inverse? My additive inverse, or the answer to my additive inverse, is going to be minus a. My additive inverse of a is going to be equal to minus a. I hope that logic is clear. So in this question you might have noticed that instead of taking a matrix to the other side, what did we actually say? We said that we'll be adding a negative of that matrix to both the sides. What did we say? We will be adding negative of a matrix to both the sides. That is the approach that we take. It is actually the same as taking to the other side, but that is not what we generally do, or that is not what we generally say. Why are we saying like that? That we will see in the later classes, because it's a little bit complicated. Why is that approach that we are taking? That is an approach that we are taking, and we will do that regularly. That is what we do. We'll try to, I'll just explain that in a later class. You will not be able to understand that right now if I try to explain that. Alright, so that is the idea that I'm going to take. So I hope the logic is clear. The concept of all the properties of matrix addition, I hope, is clear. Now let's move on to the properties of multiplication of vector with a scalar, Now that is what going to be learning now. This is something that we have already learned. Now we have already learned what is a multiplication of a vector with a scalar. Now what we are going to do is we are going to try to understand the properties of this thing. Let's try to solve it. So the first property is k into a plus b is equal to k into a plus k into b. Now let's try to understand the property. Say you have a matrix A, you have a matrix B. You take the sum of these two matrices and you multiply a scalar k to it. That is the order, right? You have a matrix A, you have a matrix B, and you have a value k. What you do is that you will add A and B first. Then you multiply k to it. You get an answer. Keep it aside. Then you have A, you multiply k with A first, then you multiply k with B first, then you add these two. You will end up getting the same answer. Confusing, right? I think you will be able to be clear with it only if I give you an option for that. So I'll give you A is equal to 1, 2, 3, 4, B is equal to minus 1, 0, 2, 4. I don't need to take 4, I'll just take 3 here. So this is going to be my two matrices, and I'm saying the k value is equal to, say, 2. Let's find out k into a plus b first. For that, what I'll do is that first I have to find out the value of a plus b. So that is going to be 2 into what is going to be my matrix a plus b. You can see this is going to be 1, and minus 1 is going to yield me 0. 2 and 0 is going to yield me 2. 2. Then again you can see 3 and 2 is going to yield me 5. And of course 4 and 3 is going to yield me 7. So you got the answer. Now you will get k into a plus b to be 0, 4, 10 and 14. So that is going to be the answer for k into a plus b. Now once you get the value of k into a plus b, the next step that you are supposed to do is you are supposed to find out the value of k into a and k into b, because that's what we are trying to prove, right? We are trying to prove k into a plus b is equal to k into a plus k into b. So let's find out k into a. Let's find out k into a. So k into a is going to be equal to 2 into this particular k into this particular number. So it is going to be very simple, 2, 4, 6 and 8. 2, 4, 6 and 8. Now let's find out k into b. And what is going to be k into b? I think it will be better if I actually go away from here so that you will have enough space. Bye-bye. Yes. K into b is going to be equal to 2 into minus 1 is going to be equal to minus 2, 0, 4 and 6. Let's find out Ka plus Kb. Now Ka plus Kb is going to be equal to a new matrix. Let's find out Ka plus Kb. Ka plus Kb is equal to 2 plus 2 is 0. Now 4 plus 0 is 4. Again 6 plus 4 is 10. Now again you have 8 plus 6 is equal to 14. You are getting the same answer for both Ka plus KB, and of course for the same one K into A plus B. Now that is how you actually show this one. Alright, so that is how you actually show the result. So that is the formula of K into A plus B is equal to KA plus KB. I hope the logic is very much clear. You can actually, what can you do? We can actually make the size of the whole thing to be a little bit small, and I'll move it here so that I'll be able to come back. Hi, I'm back. Alright, fine. So it's clear. Now let's move on to the next property. So this was my first property. I hope the first property is clear to you. Now let's move on to the next property, which is extremely simple again, which is going to be K into L into A. This is going to be my second property, is equal to K into A plus L into A. Now you can see that instead of A plus B, that means that instead of adding two matrices, here we are having two scalars being added. So what you do is that you will split it together like this. You will add K into A and L into A. So I hope that is a relatively a very simple example to understand. So again, I think it is better if we actually do it with an example. Again, I'll take the same vector, the same matrix is going to be A. We'll take the same matrix here. So it is going to be A is equal to 1, 2, 3, 4, and I'm going to take K is equal to 2, and I'm going to take L is equal to 4. So we can say K plus L is equal to 6. So the first thing that I'm going to do is K plus L, K plus L, right? K plus L into A. That is what we are going to do. So it is going to be 6 into 1, 2, 3, 4. So that is going to be equal to 6, 12, 18 and 24. 6, 12, 18 and 24. That is going to be my answer for K plus L into A. Now let's try to find out the answer for K into A and L into A. So let's find out K into A. Now what is going to be K into A is going to be 2, 4, 6 and 8. Right, it's relatively simple, I hope. And L into B, L into A is going to be equal to, L into A is going to be equal to 4 times. So it is going to be 4, 8, 12 and 16. So let's add these two. When we add K into A and L into A, you will get the answer to be 4 plus 2 is 6, 4 plus 8 is 12, 6 plus 12 is equal to 18, and 8 plus 16 is equal to 24. So you can compare the two answers, right? You can compare the two answers. All right, I'll just move a little bit away so you can see it, right? Yes, I just looked into the monitor there so that you will be able to understand, right? I've not been looking at you for a long time, so this you can see that these two are equal. Once you find that these two are equal, it is extremely easy to understand this property. So these are the properties of matrix addition, subtraction, as well as we talked about the multiplication of a vector and multiplication of a matrix and a scalar. I wrote vector, right? Multiplication of a matrix with a scalar. It is a multiplication of a matrix with a scalar. I hope the logic is very much clear. So we shall be moving on to the next important topic that we are going to cover. So we have covered enough questions also from this topic, right? So we are going to cover the concept of multiplication of matrices. Now multiplication of matrices is not that very easy. It is very easy in my opinion, but still you need to be very focused. There is a possibility of making a lot of mistakes here. So please ensure that you watch it very carefully. So let's move on to the multiplication of matrices. So we are going to look into the topic of multiplication of matrices. Now let's look into the topic. So the first concept is regarding what kind of matrices can be multiplied. So when we were talking about addition and subtraction, we said that only matrices having the same order can be added or subtracted. But in this case of multiplication, the case is a little bit different. It is not regarding the addition or subtraction. It is in addition and subtraction, you know that both of them should have equal amount or equal of order. But pardon me. Yes, I think it's clear. So it was regarding the addition and subtraction, right? It should be equal in order. But multiplication is a completely different. Oh my God, it's coming up. Yes, now I think it's clear. Multiplication is a completely different thing altogether. Now let's see how it will look like. Say for example, I'm having a matrix A which is of the order m by n, and I'm having a matrix B of the order p by q. Now when can A, B be multiplied? So A into B is called as multiplication of matrix A and matrix B. This is the multiplication of matrix A and matrix B. So this is going to be m by n, this is going to be p by q. So when I'm multiplying the two matrices M, A, B, so that is going to be called as m by n and P by Q. So that is the concept. So it is going to be M by N matrix and P by Q matrix. So we are having an M by N matrix multiplied by a P by Q matrix. It is not like you are multiplying M by N and P by Q. That is not the meaning of what I read. I just said that it is going to be a matrix of size M by N is being multiplied by another matrix of size P by Q. So in such situations, for this multiplication to exist, the condition is that N must be equal to P. The condition is that N must be equal to P. Then in such situations, the resultant matrix AB matrix will take the size M by Q. Now I hope you are able to see how the whole thing works. You are having a first matrix is of the order P by Q, M by N. The second matrix is of the order P by Q. Now you can see only if N is equal to P can A and B be multiplied. If N is not equal to P, then we say that A and B cannot be multiplied. So when do we generally say two matrices cannot be added? When they don't have the same order, right? But in case of multiplication, when do we say that two matrices cannot be multiplied? It will be in the situation where N is not equal to P. If N is equal to P, we can multiply. N not equal to P means we cannot multiply. Is that clear? So once we identify that, then of course the multiplied matrix is going to be a completely new matrix. It is not going to be A, it is not going to be B, right? If I multiply 2 and 3, you don't get 2 and 3, you get 6, completely different new number. Similarly, when you multiply two matrices, you get a new matrix, and the order of that matrix, what is going to be that order of that matrix? That is going to be M by Q. That is going to be equal to M by Q. So that is the idea of this matrix. It is going to be of the order M by Q. Is that concept clear, dear friends? Is that concept clear? So that is going to be the idea of M divided M by Q. Now in case of AB, you can basically see that. Once you let us actually write down some matrices and its orders, and we check that whether it is multipliable or not. So I say A matrix is of the order 3 by 2. I say B matrix is of the order 2 by 4. I say C matrix is of the order 2 by 3, and the D matrix is of the order 3 by 4. Now let's check which all matrices can be multiplied among themselves. You can see that I just this is not a matrix, we are just writing the order of the matrix, alright? I am not writing the matrix, instead I am writing the order of the matrix. Now we will write each one of them separately. Say if I write AB, check whether AB can exist and whether the value of what is going to be the order of the matrix AB. So the first thing that we have to check is whether AB exists or not. That is the first thing that we have to check, right? So for checking that, what is it that you are supposed to do? For checking that, what I'm going to do is I'm going to write A is going to be 3 by 2, B is going to be 2 by 4, and you can see that as we said here, N must be equal to P. In this case, you can see 2 and 2 are equal. So that means that AB can exist. Now what is going to be the order of AB? The final order of AB is going to be nothing but it is going to be 3 by 4. How did I get 3 by 4? M by Q. M and Q. Is that clear, dear friends? So it is going to be 3 by 4. I think we need more practice on that. So let's take a little bit more of a practice on that particular topic. So let me take BC. Let me see whether BC is a possible answer or not, whether we can multiply BC. Let's write down the order of the matrix BC. Let's write down the order of the matrix B and C. B is going to be 2 by 4 matrix. C is going to be 2 by 3 matrix. So you can say that 2 is 4 and 2 are not equal. So you say that this matrix multiplication cannot be done. This matrix multiplication cannot be done. That is the most important part of it. That means that BC cannot exist altogether. Alright, so that is the logic. That the logic is that BC cannot exist altogether at all. Now we are going to look more of that, right? Let me take and look more of that. Say, let me take CD. Let's take CD. So what is going to be the order of C and D respectively? The order of C is going to be 2 by 3. The order of D is going to be 3 by 4. Now let's check whether it is possible to exist or not. Whether possible to exist, this is 3 and this is 3. Yes, N is equal to P. So what is going to be the final order of the matrix is going to be 2 by 4. Yes, the final order of the matrix is going to be 2 by 4. So this is the logic that we have to study. That is the first step that you have to study. The first step is that you have to you have to check whether there is a possibility of an existence of multiplication. You have to check for the possibility of an existence of multiplication. Only when there is a possibility of existence of a multiplication do we say that we can have multiplication of matrices. Is that clear all together? All right, fine. I hope the logic is clear. Now we will be moving on to the next concept in which we will be actually doing the multiplication. What we did now is that we will just check the possibility of multiplying. Once you understand the possibility that a multiplication can exist, now we need to know how to do that multiplication, right? So that will be doing now. We'll be checking into the possibility of multiplication of two matrices. Now let's look into that, the possibility of multiplication of matrices. So we have discussed about the basic idea of multiplication, in which we will be actually understanding. We understood how the number of whether to decide whether a particular multiplication of matrices can be done or not. That kind of decision making we have done. Now once it is done, let's see how to do the multiplication. So first I'm going to give you an example. So the first question that I'm going to take is, I'm going to take a matrix A, and that is going to be 2, 1, 3, 4, 0, minus 2. So this is going to be of the order. First let me check the order. It is going to be of the order 2 by 3 matrix. Next I'm going to write another matrix which is going to be of the order 2, 1, 0, minus 1. So this is going to be my next matrix, and this is going to be of the order, this is going to be of the order 3 by 2. So you can see that I have taken two matrices. One is going to be a 2 by 3 matrix and the other is going to be a 3 by 2 matrix. So the first step, and we are asked to find AB. We are asked to find AB. So when I'm asked to do the multiplication of two matrices, the first step that we have to do is to check whether we will be able to do this multiplication or not. That is the first step that we have to do. And in that first step, let me check whether we will be able to find AB, because A happens to be a 2 by 3 matrix and B happens to be a 3 by 2 matrix. So you can see that this 3 and this 3 are equal. So that means that the multiplication is possible, and the overall order of the final matrix is going to be 2 by 2. Overall order of the final matrix is going to be of the order 2 by 2 matrix. Is that clear, dear friends? I really hope the concept is clear to you. Alright, so once the concept is clear, now we shall move on and try to understand how to actually write this. So we know that AB matrix is going to be of the order 2 by 2. So what I'm going to do is I am going to first write that matrix 2 by 2. So this is going to be A11, this is going to be A12, this is going to be A21, and this is going to be A22. So this is going to be my final AB matrix. Is that clear, everyone? I have not got the final answer, but I understood the basic structure of that matrix, and I identified that there is going to be a 2 by 2 matrix, and I also wrote down the element numbers. Alright, so first I will be finding out each one of the elements separately. First we will be find out 1, 1, A11. So let's find out A11 first. So A11 is going to be, now you can see that 1, 1, that is a term that we are trying to find out, right? This is going to be first row and first column. So in order to do the multiplication, what you are supposed to do is you have to multiply the first row of the first matrix and first column of the second matrix. You can see here 1, 1. So 1, 1 is standing for, you multiply the first row of the first matrix and first column of the second matrix. Now if I am talking about A12, A12 is going to be, it is going to be 1 and 2, right? So you have to multiply the first row of the first matrix and second column of the second matrix. Is that clear, everyone? So this is actually giving you the clue on how to do the multiplication. Which row and which column has to be multiplied. That is the clue that you will end up getting here. Alright, so that means that matrix multiplication involves multiplication of rows and columns. Now once you have to know which is row and which column you have to multiply, that clue will be given by this particular number. Now if I am going to write A21, so what is going to be A21 multiplication going to be? A21 multiplication involves second row and first column. What is going to be A22? A22 is going to be second row and second column. Is that idea clear to everyone? Now let's write it once again. So what is going to be A11? A11, we have to multiply the first row into first column. So you can see that, or I'll write R1 and C1. I think that will be better, right? So I'll write R1 into C1. So what does that R1 means? R1 is for the first matrix and this is column is for the second matrix. Now for the next case, it is going to be R1 into C2. It is going to be row 1 into column 2, A12. The next is going to be for R2 into C1, it is going to be row 2 into column 1, and the next one is going to be R2 into C2, that is row 2 into C2. So you can see 2 2 2 2, 2 1 2 1, 1 2 1 2, 1 1 1 1. Is that idea clear to everyone? I really hope that the concept is very much clear to you. Fine. So once it is clear, now let us see how to do this multiplication. That is the next step, right? So we are learning multiplication of matrices in a step-by-step manner. In the first step, we have ensured that how to check whether a multiplication can be done or not. Now once we have decided that the multiplication can be done, then we wrote that matrix, we wrote the order of that matrix, and then we took individual each terms and we decided on which row and which column to do the multiplication on. Now once we decide which row and which column has to be multiplied, next we have to know how to do that multiplication. Now let's go there. So we have taken it to the next page. Now let's see how to find out AB. Now AB involves the first row and first column, we know that, so I'm going to find out A11, and A11 is going to be R1 into C1. So let's first take R1. So you can see this is going to be your R1 and this is going to be your C1. So let's multiply R1 and C1. For that, what we will do is that we will multiply the first elements together, then the second elements together, and then the third elements together. So that means that I'm going to multiply 2 into 1. So it is going to be 2 into 1. Now where did I get this 2 and 1 from? I multiplied the first elements of those row and column. So I decided to multiply R1 and C1. Once you decide that, then you multiply the first elements together, then the second elements together, and then the third elements together. Now you can see that 2 into 1 is going to be my first term, then it is going to be 1 into 2 is going to be my next multiplication to be done, and the last is going to be 3 into 0. So your answer is going to be 2 plus 2, which is equal to 4. So what is going to be your A11 going to be? A11 is going to be equal to 4. Now when we are looking for A22, I know that you are almost clear of it, but we are not very much clear of it. So it is not A22, we have to go for A12 next. Now what is A12 going to be? R1 into C2. That means that you have to multiply your row 1 and second column. First row and second column. So let's do the first row and the second column here. So this is going to be my second column. You can see it here. So first row into second column. What should I multiply? First elements together, second elements together, and the third elements together. So let's multiply it. So it is going to be 4 into 2. 4 into 2. Clear everyone? The next one is going to be 1 into 1, it is going to be 1 into 1, and the next one is going to be 3 into minus 1, and the next one is going to be 3 into minus 1. So it is going to be 8 plus 1 minus 3, which is equal to 9 minus 3, that is equal to 6. So you can see that your A11 and A12 is clear to you, right? Now once you're clear with A11 and A12, let's go for the next one, right? Let's go for the next one, and the next one is going to be A21. A21 involves multiplying second row and first column. So I'm going to take my second row and first column. So what is going to be my second row? 4, 1, 0, 2, and minus 2, 0. Let's do that multiplication, shall we? So what is going to be my A21? My A21 is going to be 4 into 1 plus 0 into 2 plus minus 2 into 0. I hope you are able to get the logic. Now you can see this is going to be 4 plus 0, which is equal to 4. So you got the value for A21. Now let's go for A22. Let's go for A22. Going for A22 means I'll have to choose the second row and second column. Now that involves, everyone please do it on your own. In my opinion, do it on your own. So you will get it. So 4 into 4 plus 0 into 1 plus minus 2 into minus 1. Did you get it? Did you get it? Yes, it is going to be 16 plus 0 plus 2, which is equal to 18. So you got the value of all the 4 elements of the 2 by 2 matrix. You got all the elements of the 2 by 2 matrix. So now shall we actually bring all of them together? Now we can say what is going to be my AB matrix. What is going to be my final answer for my AB matrix, which is going to be equal to, what is going to be my A11? That is going to be equal to 4. So here position is going to give me, this position will have the answer 4. What is going to be A12 is going to be 6. So you will write the 6 here. Now let's go for A22. A21 is going to be 4 again, so you will write another 4 here, and here you will have 18. So this is going to be the product AB. So we have just multiplied matrix A and matrix B and we got the answer. So you can see that we did it over 3 different important stages. You can say that you cannot say it as steps because steps would not be the right way to say it. We have to go through 3 different stages in order to actually come to the end of a multiplication of matrices. So let's revise the whole thing once again so that it keeps very much firm, it is kept very firm in your mind. So the first thing that you have to do when 2 matrices are given to you and you are asked to multiply these 2 matrices, what you have to do is you have to decide whether these matrices can be multiplied or not. Is that clear? That is the first step that you have to do. You have to decide whether you will be able to multiply these matrices or not. If you want to make that decision, what is the step that you have to do? You have to identify the order of the first matrix to be multiplied. Then you have to identify the order of the second matrix to be multiplied. Then write it together like this, and you have to check whether n is equal to p, where m by n and p by q are the orders of the first and the second matrices respectively. If n is equal to p, then we can say it is going to be multiplied. We can multiply, that's true. And the product AB, the matrix AB, will have the order m by q, where m is taken from the first one and q is taken from the next one. So I hope the logic is clear. So then we check certain questions in which I gave you 4 different orders of matrices, and we checked for the existence of AB, BC and CD, and we found that AB and CD can exist whereas BC cannot exist. I really hope you remember this one. I will not be repeating the whole thing again. Then we took a question in which again we understood what we checked, whether AB can exist or not. Then we decided that AB can exist, and then we found out the order of AB. Once you find the order of AB, the next step is to write down a matrix like this and write down all the elements. So you can see that this is a 2 by 2 matrix in this case. So it has how many elements? 2 into 2 is 4. So that means that it has 4 elements. The maximum size that you will have to be multiply is going to be 3 by 3. That means that no order greater than that will generally not be asked. The maximum number of elements that you will have to write is 9. That is a maximum number. So don't worry about writing a lot, but if it is a 5-mark question or say a larger question, then you can expect you to write a lot of elements. So in this case, you can see you have to write down 4 elements, and you write A11, A12, A21 and A22. Once you identify the 4 elements here, now you have to write what is it that you have to multiply. That you identified as A11 stands for first row and first column, A12 stands for first row and second column, A21 stands for second row and first column, A22 stands for second row and second column. Say for instance I am giving you something trivial. So if I give Aij, what is it standing for? Aij stands for ith row of first column, first matrix, and jth column of second matrix. Is that clear? It is standing for ith row of first matrix. You can see this number is always taken from the first matrix and the second one is always taken from the second matrix. So I is taken from the first matrix and that is standing for a row. So ith row and jth column. That is going to be the logic for Aij. Is that clear, everyone? You can expect these kind of questions also, randomly asking for a particular term. That can also be asked, especially when you are focusing on the competitive examinations. All right. So that is how it is going to be. So you can see that we understood that, and we are finding out each one of the elements separately. A12, A21, A22 and A12. All these 4 elements are individually found out. So when we are finding out this one, you said that when you are multiplying 2 matrices, and I say you have to multiply first row and first column, that means that first row and first column involves multiplying first corresponding elements, next corresponding elements, next corresponding elements. So you'll end up getting the answer. Again, when you are looking for the multiplication of A12, you can see first row and second column, you will be multiplying first and first, second and second, third and third. Is that clear? Again, when you are going for the next one, A21, you will be going for first, second row and first column. Again, it is going to be first terms, second terms and third terms that are being multiplied together. Is that logic clear, everyone? I really hope that logic is becoming a little bit more clearer to you, right? So that is it. So it is going to be A21 and A22. So we got the answer AB matrix in that sense. So I really hope that is clear to you. But of course, we just repeated the concept for one question. I think it will be better if we are able to do one more question, right? So let's do one more question without wasting much time. So let's go for one more question. So let's do a question. Yes, let me write down the question for you. I'll write down the question for you. So your multiplication A, or the first matrix A, is going to be 1, 4, 2, 3. Now that is going to be of the order 2 by 2. I'm going to take the second matrix, and that is going to be 1, minus 1, 2, 0, 4 and 5. So you can see this is of the order 2 by 3. This is of the order 2 by 3 matrix. So you can see, let's try to multiply these two. We know that the first step that we have to do is to find out whether AB can exist or not. Now we will do that by writing 2 by 2 matrix into a 2 by 3 matrix. So you can see this is a 2 and this is a 2. That means that you can have this can exist, and the final order is going to be how much? And the final order is going to be a 2 by 3 matrix. So that means that AB is going to be how much? It is going to be a 2 by 3 matrix. So let me write down AB for you. AB is going to have 2 rows and 3 columns. That is A11, A12 and A13. It will have A21, A22 and A23. So this is going to be the structure of what? It is going to be the structure of AB matrix. AB matrix will be a 2 by 3 matrix in which these elements will be present. Is that clear, everyone? I hope I'm going in the same route exactly as earlier itself, right? Now let's go for the next one. Let's try to solve it. Let's try to solve this one, right? Let's try to solve it. So it is going to be, I'm going to find each one of them individually. I have to find A11. The first thing I have to do is I have to find the value of A11. So A11 involves first row and first column. First row and first column. Is that clear, everyone? A11. I'm not going to write everything now. I'm just going to write 1 into 1 and 4 into 0. I'm just going to write 1 into 1 and 4 into 0. So I hope I'm reducing the number of steps, right? 1 into 1 plus 4 into 0. So your answer is going to be equal to 1. Is that clear, dear friends? For A11 is standing for first row and first column. Now let's go for the next one. Next one is going to be, I'm choosing A12. A12 involves first row and second column. So I'll just write it for you. A12 is going to be equal to first row and second column. So what is going to be the first row? It is going to be 1 into minus 1 and 4 into 4. It is going to be 1 into minus 1. 1 into minus 1 plus 4 into 4, which involves 16 minus 1, which is equal to 15. That is going to be my A12. Now let's go for A13. Now what is A13? A13 is going to be first row into third column. That is going to be A13. First row into third column. First row into third column. That is 1 into 2 plus 4 into 5. So let's write it down. It is going to be 1 into 2 plus 4 into 5, which is going to involve 22, which is going to be 20 plus 2, which is equal to 22. Is that clear, dear friends? I'm going a little bit fast, but I really hope you are catching up with me, right? I know you can catch up with me. It's not that difficult for you. So let me go for A21. Now that is going to be second row and first column. Second row and first column. So that is going to be how much? 2 into 1 and 3 into 0. That is going to be 2 into 1. I'm sorry. 2 into 1 and 3 into 0. For your answer is going to be how much? Your answer is going to be 0. Now let's go for the next one, and the next one involves A22. Next one involves A22. So let's solve A22. A22 is going to be second row into second column. That is 2 into minus 1 and 3 into 4. It is going to be 2 into minus 1. 2 into minus 1 and 3 into 4. Right? Am I correct? Yes. 2 into minus 1 and 3 into 4. Sometimes we may get confused, you know. Many common mistakes can happen, and your answer is going to be 10. Now let's go for the last one. Let's go for the last one, and the last one is going to be A23. Let's find out the value of A23 for you. A23 is going to be second row into third column. That involves 2 into 2 and 3 into 5. That is going to be 2 into 2 and 3 into 5. 2 into 2 plus 3 into 5 is going to be 4 plus 15, which is equal to 19. Now you got the whole matrix for yourself, right? So let's write down the matrix for you. The whole matrix AB is going to be equal to 1, 15 and 22, 2, 10 and 19. So this is going to be my final AB matrix. Is that idea clear to you, man? I hope this logic is very much clear, right? Because A11, A12, A13, A21, A22 and A23. So this is how we do the certain multiplications of matrices. So we just did two important multiplication of matrices, but this is not enough. Of course, you want to practice more, but I really hope the concept is very much clear to you. Once the concept of this multiplication of matrices are clear, you may start doing the questions from NCERT textbook exercise 3.2. The first initial questions are very much, I hope it is of the same model. So try to do it, of course. So I really hope the multiplication of matrices has been clear to you. Now we'll be moving on to the next important topic, which is going to be called as properties of matrix multiplication. So let's continue with properties of matrix multiplication. So in matrix multiplication, the first property that we are going to study is associative law. The first property that we are going to study is associative property. So I hope you remember what we studied in associative property in matrix addition, right? In addition, we studied that it is going to be, say, A plus B plus C is equal to A plus B plus C. This was the associative property in matrix addition. So it was associative, it is concerning about three matrices, not two, but it involved three matrices. So similarly, here also we have three matrices, and your property will look something like this: A into BC is equal to AB into C. So the property looks, let me explain what it means. The concept is that we have to multiply three matrices. Alright, so we have to multiply, say, it is like multiplying three numbers, 2 into 3 into 4. So the doubt that comes in our mind is, should I first multiply B and C and then I should multiply it with A? Or should I multiply A and B, then I should multiply the result with C? That is a doubt that we will have. So such a kind of doubt is not required at all, because in my opinion, because in both the cases you will end up getting the same answer. That means that it doesn't matter if you multiply BC and then you multiply the result with A, or whether you multiply AB and you multiply the result with C, both are going to yield you the same result. So that is the concept of associative property. So but for understanding the concept of associative property, in my opinion, it is always better to go with the problem. So we are taking a problem, and we can see that there are three matrices that is in front of me. So that is going to be a matrix A, matrix B and matrix C, and we can see that this is an example from your NCERT textbook itself. So let's do an example from NCERT textbook, and I'm going to take the matrices. So the first thing that I have to check is, we have to show that AB into C is equal to A into BC. So exactly what we are saying, right? That is the same concept that we are trying to do. So first let me go with my LHS, right? So first let us go with the left hand side. So let's start with AB into C. So first we have to find AB. For doing AB, the first thing that we have to check is whether it is possible to multiply it or not. So what is going to be the order of A? A is going to be a 3 by 3 matrix. So it is 3 and 3. This is going to be a 3 by 2 matrix. So the B is going to be a 3 by 2 matrix. It is also perfectly possible. And C is going to be a 2 by 4 matrix. So that is all right. So we can see, when I'm talking about AB, we can see that 3 and 3 are coming in here. So we can say that we can multiply these two matrices. It is perfectly possible to actually multiply these two matrices. It's fine, and the answer will yield me a 3 by 2 matrix. So what is going to be the order of my final answer? It is going to be a 3 by 2 matrix, which involves A11, A12. That means that we have to have 3 rows and 2 columns. So again, it is going to be A21, A22 and A31 and A32, and my matrix is going to be of the order 3 by 2. My matrix is going to be of the order 3 by 2. Is that clear, dear friends? Now that's done regarding AB. Now let's go for the next concept. Let's go for the next concept, and that is going to be how much? That is going to be, let's find out the answers. For finding out the answer, what I have to do is I have to first find A11, right? First I have to find A11, and I'm going to find A11 first. I'll just highlight it in different colors so it will be cleared for you. Now A11 involves multiplying first row and first column. You can see that I'm not going to write everything like then the last question. Instead, I'm just writing this matrix. I identified all the terms. Now I'll just do the multiplication as such in my mind. That is how it should be done. So it should involve first row and first column. So that is going to be 1 into 1. That is going to be my first term. That is 1 into 1. Plus another term is going to be 1 into 0 plus 1 into 0, and the next is going to be minus 1 into minus 1, and it is going to be minus 1 into minus 1. That is going to be my A11. That is going to be my A11. So you can see this is 1, this is 0, and this is 1. So your total answer is going to be equal to how much? It is going to be 1 plus 0 plus 1. That is going to be my A11. Is that clear, dear friends? Now let's go for A12. A12 again involves first row and second column. So first row and second column involves, you can see first 1 into 3 is going to yield me 3. 1 into 3 is going to yield me 3, and the next is going to be 1 into 2 is going to yield me 2, and the last one is going to be minus 1 into 4 is going to yield me minus 4. So it is going to be minus 4. So this is going to be my A12. So you got the value of A11 and A12. Now it's clear. So shall we go ahead? We'll be going for looking for the value of A21. A21 involves second row and first column. Second row and first column. So second row involves 2 into 1 is going to be 2. plus, now it is going to be 0 into 0 is going to be equal to 0, and the third one is going to be 3 into minus 1 is going to be minus 3. So that is going to be my A21. So I hope the concept of A21 is also very much clear to you. Now let's look for A22. A22 is going to be, shall I make it a little bit quicker? A22 is going to be equal to 2 into 3 is 6, 0 into 2 is 0, and A22, right? So 3 into 4 is going to be 12. So that is how I wrote it. Actually I skipped every step, so I hope you can see how we are actually improving our level. So 2 into 3 is 6, 0 into 2 is 0, 3 into 4 is 12, so 6 plus 0 plus 12. Now again I'm going for the last one, and last one involved 3 into 1 is 3, minus 1 into 0 is 0, 2 into minus 1 is minus 2, so this is going to be A31. Again I'll just show it to you. 3 into 1 is going to be 3, you can see minus 1 into 0 is going to be 0, and 2 into minus 1 is going to be minus 2. Is that clear? Now let's go for the last one, and the last one involves 3 into 3 is 9, minus 1 into 2 is minus 2, and the last one is going to be 2 into 4 is going to be 8. Now let's see again what is going to be A32, third row into second column. What is going to be 3 into 3 is 9, minus 1 into 2 is minus 2, and 2 into 4 is equal to 8. Now let's simplify the whole expression, right? So let's simplify the whole expression, and simplifying the expression is going to yield me AB is going to be equal to 2. That is going to be, one side is 3 plus 2 is 5, 5 minus 4 is 1, so 2, 1, and 2 plus 0 minus 3 is going to yield me minus 1, and the 6 plus 12 is going to give me 18, then the last one is going to give me 3 minus 2 is 1, and 9 minus 2 is 7, and 7 plus 8 is going to be 15. So this is going to be the answer for AB. This is going to be the answer for AB. Is that clear, dear friends? Is that clear? That is going to be my answer for AB. So I really hope the concept is very much clear to you. AB we know is going to be equal to 2, 1, minus 1, 18, 115. 2, 1, 2, 1, minus 1, 18, 15. So that is going to be my AB. That is going to be of the order 3 by 2 matrix. Let's write down C to be 1, 2, 3, minus 4, and the last one is going to be 2, 0, minus 2, 1. 2, 0, minus 2, 1. So that is going to be the answer for C. Let's find out AB into C is going to yield me, this is, you can see that it is a 2 by 2. This is going to be a 2 by 4 matrix. So it's going to yield me a very huge matrix. It is going to yield me a very huge matrix, which is going to be, this is going to be 2 by 2, and the final matrix is of the order 3 by 4 matrix. Oh, that's going to be huge. ABC is going to be a 3 by 4 matrix. So it is going to take up a lot of space, my friends. A11, A12, A13, and A14. Then of course you have A21, A22, A23, and A24. Then you have A31, A32, A33, and A34. Now this is going to be your matrix, the final matrix. So let's take up the value of A11. Now what is going to be A11? You can see I'll be skipping more steps now. So you can see it is going to be 2 into 1 is 2, plus 1 into 2 is 2, so 2 plus 2 is 4. So I really hope you are able to catch what I'm trying to do. Okay, so I'm skipping the steps more. So you have to understand how to write steps, you have to understand how to skip steps. Both are extremely important, alright? Because when you are writing in a competitive examination, you might end up writing minimum number of steps. When you are going for a board examination, you have to go for maximum number of steps. So you should be very comfortable with both the methods. So the first one is going to be A11. The first one is going to be A11, and that is going to be 2 into 1 plus 1 into 2 is going to be equal to 4. The next is going to be A12, that is first row and second column, that is going to be 2 into 2 plus 1 into 0, which is going to be again 4 plus 0, which is 4. The next is going to be first row into third column, that is going to be 2 into 3 is 6. 6 minus 2 is 4. You can see this is a 4. It is a lot of 4s coming in the answer. That's fine. So let's go ahead with the last. What is going to be A14 is going to be first row into fourth column. So it is going to be 2 into minus 4 is minus 8. 1 into 1 is 1. So it is going to be minus 8 plus 1, which is going to be equal to minus 7. So I hope the concept is very much clear to you. The logic, I think, is coming to you very clearly, right? Now let's go ahead and solve the next one, which is going to be A21. What is going to be A21? Second row into first column. So it is going to be minus 1 into 1 is minus 1. 18 into 2 is 36. So you can see that is going to be 36 minus 1 is 35. So you can see it is going to be 35. Now let's go ahead and solve the next question. So that is going to be A22 is second row into second column. That involves minus 1 into 2 and 18 into 0. So you can see it is going to be minus 2 alone is going to be the last portion. Now let's go for say A23, right? A23 is going to be second row into third column. That is going to be minus 1 into 3 is minus 3. 18 into minus 2 is minus 36. So it is minus 36 minus 3 is minus 39. So you will get the answer to be minus 39. The next is going to be again A24, that is second row and fourth column. Again minus 1 into minus 4 is going to be 4. 18 into 1 is 18. So it is going to be 4 plus 18, which is equal to 22. Very good. Is that clear here, friends? So let's go ahead and do the next one, which is going to be A31. A31 involves 1 plus 30, which is equal to 31. The next is going to be 2 plus 0, which is equal to 2. Added those two in mind. So I hope you are able to do it in mind also. Try to do it on your mind, alright? So when I'm doing along with me, you see it, you pause the video, try to do it in your mind along with me. Alright, I know I'm pushing my limits. You know, I'm just pushing your limits. Just try to push it, alright? Don't be slow. Try to push your limits. Sometimes you might be able to come along with me. Sometimes you may lag behind me. Both might happen. That is because, of course, I am a teacher and I have been teaching for so many years. I'll be, of course, be faster. But of course, you are actually learning. So you might actually need a little bit of push, and if you feel that you are a little bit slow, pause the video and then try to do it on your own, then see my video. So what I hope you are able to understand, because I will be trying to push you a little bit, so sometimes you may not come along with me. Don't worry at all. You don't have to worry, because I am pushing you. Understand that I am pushing you. It's okay if you fall behind, but don't stay there. Come up and walk along with me. That is what you have to do. Alright? Even if you slow down, come up, get up and walk along with me. Slowly you get up. I'll be waiting for you. Alright? Fine. So please understand that. Okay, so this is going to be, next is going to be, of course, we are talking about A31, which I did it in my mind, which is going to be 1 into 1 plus 15 into 2, that is going to be 1 plus 30, 31. Next is going to be 1 into 2 and 15 into 0 is going to be 2. Again, the next is going to be 3 plus minus 30 minus 27. Try to do it. 3 plus minus 30 is minus 27. If you feel it is difficult, pause the video and think. Don't write anything. Use your mind to think what I said and check whether you are getting minus 27. Alright? But anyway, I'm going to explain that to you. Of course, I hope you have tried it, if you have paused it and tried it. Alright? If you have not paused it and tried it, do it. Only then continue watching the video. Alright? Fine. Very good. I hope you have done it so. So I'm going to explain the answer. So it is going to be 1 into 3 is going to be 3. And the next is going to be 15 into minus 2 is minus 30. So you have a 3 minus 30, which is going to yield you minus 27. And the next is going to be again 1 into minus 4 is minus 4. 15 into 1 is 15. So it is going to be 11. It is going to be 11. So this is going to be the answer for A, B into C. We have written not A, B, C. We have written A, B into C. Alright. I hope the logic is clear. So shall we move on and try to check the other one around. What is that going to be? A into B, C. So let's take each one of them separately. So first I am going to multiply. When I want to find out A into B, C, what we are supposed to do is we have to first find out the value of B, C first. And once you get the value of B, C, then you have to multiply it with A. That is the most important thing. So let's multiply first B, C first. So let's consider B is going to be of the order 3 by 2 and C is of the order 2 by 4. So you can see that you will end up getting the answer to be in the form of 3 by 4 matrix. So let me actually write the BC matrix first for you. So it is going to be a 3 by 4 matrix, 1 1 A11, A12, A13 and A14, A21, A22, A23 and A24. Then you will have A31, A32, A33 and A34. So next I'll be writing the answer here, of course. So let's try to solve. First we'll try to solve the concept of, we'll try to solve the A11 first. So let's solve A11. What is going to be A11? That is going to be first row into first column. Alright, there's going to be A11 is first row into first column is again 1 plus 6, right? It is going to be 1 plus 6, which is equal to 7. Are you able to follow what I just did? 1 into 1 plus 3 into 2, which is going to be equal to 6 plus 1 is 7. Alright, now you are seeing that I'm not writing it again once again. You can see that I did not actually write down, but I'm looking at the question here and trying to solve it instead of writing everything down as I did earlier, right? Earlier I used to write everything down, but in this method I'm not actually writing everything down. I'm just looking at it and trying to solve it. So that is going to give me 1 into 3. 1 into 1 is going to be 1, plus 3 into 2 is going to be 6, plus 1 is 7. Now 1 into 2 is 2, 3 into 0 is 0, so it is going to be 2. The next is going to be again first row into third column is 1 into 3 is 3, 3 into minus 2 is minus 6. So it is going to be 3 minus 6, which is equal to minus 3. Okay, I hope you are pausing the video and try to do the whole thing on your own. First, try to solve everything on your own and do it exactly in your mind. If you feel that you can do it in your mind, do it in your mind. If you feel that you cannot do it in mind, then write down every step individually. Okay, write down every step individually exactly as I did earlier, because in this concept I just wrote down every single step. Then I skipped, in the next one I skipped one step. Here again I'm skipping more steps. So you can see that I am skipping steps as I go further. You may choose to do it, you may not choose to do it. It is up to you. It is up to you what your level of confidence is. I'm just showing you there are different ways of doing the concept. Alright, fine. So let's do it again. I reached till it is going to be A13. It is first row into third column. Next is going to be first row into fourth column, which is going to be minus 4 plus 3 is minus 1. Minus 4 plus 3 is minus 1. Minus 4 is 1 into minus 4, and 3 into 1 is going to be like that. Next is going to be A21. That is going to be second row and first column. 0 into 1 plus 2 into 2 is 4. Next is going to be 0 into 2 is 0. 2 into 0 is 0. So you'll get the answer to be equal to 0. Next is going to be 0 into 3 is 0. 2 into minus 2 is minus 4. See how quickly you can do it. Next is going to be 0 into minus 4 is 0. 2 into 2 is 2. 2 into 1 is 2. I'm sorry. Next is going to be minus 1 plus 8 is going to minus 1 plus 8 is going to yield me 7. Next is going to be minus 2 plus 0 is going to yield me minus 2. Then it is going to be minus 3 plus minus 8. Minus 3 plus minus 8 is going to yield me minus 11, and minus 4 into minus 1 into minus 4 is 4. So 4 plus 4 is going to yield me 8. So this is going to be the answer for BC. Now I think that is the correct answer for BC. Is that clear, dear friends? Yes, I really think so. This is the correct answer for BC. Now let's find out the value of A into BC, shall we? Now I'm going to find out the value of A into BC. Now we can see that this is of the order 3 by 3 and this is of the order 3 by 4. So what is going to be the final answer going to take? It is again going to take the order 3 by 4. It should take the order 3 by 4, right? Why? Because your AB into C is going to be of the order 3 by 4. So the final answer should also be of the form 3 by 4. So you will again have what? It is again going to have this form. So you have to multiply this one and this one, right? That is what you are supposed to do. So it is going to be A into BC. So let's do it individually. Now it is going to yield me 1 into 7 is 7. So 7 plus 4 minus 7. So it is going to be 7 plus 4 minus 7 is going to yield me 4. So the first term 4. Good. Let's go for the next one. Next is going to be again for A12, right? So it is going to be A1 into 2. So let's do it. 1 into 2 is 2. 1 into 0 is 0. Minus 1 into minus 2 is 2. So it is going to be 2 plus 2 is going to be equal to again 4. Very good. Now let's go for A13. A13 is going to be first row into third column. It is going to be first row into third column. So let's do it. Now that is going to yield me 1 into minus 3 is going to be minus 3. 1 into minus 4 is going to be equal to minus 4. So it is going to be minus 3. Minus 4 is minus 7 till now. Minus 1 into minus 11 is going to be 11. So that means that is going to be minus 7 plus 11 going to yield me again another 4. Alright, I hope the logic is clear. Now let's go for A14. Now A14 is going to be first row into fourth column. So that is going to yield me minus 1 plus 2 minus 8. Minus 1 plus 2 is going to be how much? 1 minus 8 is going to be equal to minus 7. So you can see the first row is getting correct. 4, 4, 4 minus 7. 4, 4, 4 minus 7. So it's fine. The first row is pakka. Now let's go for the second row. Second row is going to be again, this is the row that we are going to solve. So it is going to be second, A21 is going to be second row into first column. Second row into first column. So let's solve it. It is going to be 7 into 2 is 14. 0 into 1, 4 is 0. 3 into 7 is 21. So it is going to be how much? 2 into 7 is 14 plus 3 into 7 is going to be 21. So the answer is going to be 35, right? Yes, 35. You can see you have a 35 there. Now let's go for the next one. It is going to be A22. A22 is going to be second row into second column. That is going to be second row into second column. That is going to be 2 into 2 is 4, 0 into 0 is 0, and 3 into minus 2 is minus 6. That means that I'll have 4 minus 6, which is going to yield me minus 2. Check here. Minus 2. It is correct. So you can see we are matching it. Till now we have been very perfect. Now let's go for the next one. The next one is involving A23. That is second row and third column. That is going to be second row and third column. So again we will do 2 into 3 minus 3 is minus 6. 0 is going to yield me 0, and 3 into minus 3 is minus 33. So you can see it is going to be minus 6 minus 33. So it is going to yield me minus 39. It is going to yield me minus 39. Now check. Yes, you have a minus 39 here. Oh, it is going very good, right? It is going very good. Now let's go for the next one. That is going to be A24. A24 has yielded me second row into fourth column. It is going to be second row into fourth column. So again we can see 2 into minus 1 is minus 2. Then you have 0 here, so it doesn't matter. And the last is going to be 3 into 8 is how much? 24. So it is minus 2 plus 24, which is going to yield me 22. So is it correct? Yes, we have the answer to be 22 here. So first two rows are perfectly matching now, right? Now we have to go for the third row. Now let's look for the third row. Third row, I'm going to look for A31. So A31 involves third row and first column. It is third row and first column. So let's do it. 3 into 7 is going to be 21. Minus 1 into 4 is going to be minus 4. 21 minus 4, it is going to be 17. Now 17 plus 14 is going to yield me 31. So that is going to be my answer. I hope you are doing it on your own and just use my words to check what you have written. Alright? If you have made any mistakes, do it again. Don't copy what I am doing. You just use what I am saying to check what you have done. If you have made a mistake, pause, then correct your mistake, then go forward. That is how you're supposed to do it. That is why I'm not writing, instead I'm saying. Alright? Fine. The next is going to be again A32. Next is going to be A32. That means you have to go third row and second column. That is going to be 3 into 2 is 6. 0 in minus 1 into 0 is 0. And 2 into minus 2 is minus 4. So it is going to be 6 minus 4 is going to be equal to 2. Check. Correct. Now let's look for the A33. A33 is going to be third row into third column. It is going to be third row into third column, which involves 3 into minus 3 is minus 9. 3 into minus 3 is minus 9. Keep it in mind. Minus 1 into minus 4 is plus 4. So it is going to be minus 9 plus 4 is minus 5. Keep it in mind. Minus 5. Then of course minus 5 and minus 22 is going to yield me minus 27. So check whether you have minus 27. Yes, you have minus 27. Only one more term remaining, and if that term turns out to be correct, that means that we have proved the associative property, right? So let's try to solve it. The last term is going to be, yes, we are going to solve the last term. Keep your fingers crossed, right? Let's keep the fingers crossed. It is going to be A34, third row into fourth column. Let's do it. It is going to be 3 into minus 1 is minus 3. Minus 1 into 2 is minus 2. So minus 3 plus minus 2 is minus 5. And 8 into 2 is tends to be 16. So minus 5 plus 16 is going to yield me 11. Yes, we have the number 11 and we have matched it. Perfect match. That means that we have just proved AB into C is equal to A into BC. We have just proved AB into C is equal to A into BC. Is that clear, dear friends? I really hope it is clear. So shall we move on? And we have understood the concept of associative property now, and we have proved the concept of associative property. So once associative property is clear, then we will have to look for the concept of distributive property. Now let's study the next property, which is called as distributive property. Am I going a little bit fast for you? Yes, I am. I know, because why should we go slowly, man? You can go fast. If you feel that you need a break, just pause the video and take a small break. That's it. Alright? Fine. Now let's go into the next property, which is going to be called as distributive property. And let's see what is distributive property. That is A into B plus C is equal to AB plus AC. Now again, that seems to be an interesting property. That is A into B plus C is equal to AB plus AC. Now we know that we have certain conditions for all these things, and let me take a question again from the NCERT textbook. You can see this question is example 17 and we are asked to verify A plus B into C is equal to AC plus BC. Again the concept of distributive property itself, it's just that C is on the other side, but when I wrote it on this side. That is the only difference that we have. No, not much of a difference. So that is it. Now we will be actually trying to solve this question, which is going to be A plus B into C is equal to AC plus BC. So shall we do it now? Yes, we shall. So we will be continuing to solve question number 17, in which we will be trying to understand the distributive law. So first I am going to take my LHS. So taking the LHS involved, first I have to add A plus B. So for adding A plus B, what we have to check is that we have to check whether A and B is of the same order. So let me check. The order of A is equal to 3 by 3 and order of B is equal to another 3 by 3. So we can see that the order of A and B are same, so it is possible to add A and B. So let's find out the value of A plus B. I think that is a very direct question. We have already done so many questions on that front. So I think it is going to be relatively easy and we are going to solve it directly by looking at it. So we'll be adding 0 and 0, you end up getting another 0. Then we will add 6 and 1, you will end up getting 7. Then we will add 7 and 1, we will end up getting 8. So I hope you are coming along with me, right? In my opinion, do it, and then once you have completed it, then just use this video to check your answer. Don't look at it and write the answer, because that is not useful for you. That is not how you are supposed to do. You know what is addition of, you know how to do the addition of matrices. So just add the matrices on your own and just ensure that you just use this video to check it. Alright, so again we are going for, pardon me, minus 6 plus 1 is equal to minus 5. Next we have 0 plus 0 is equal to 0. Then we have 8 plus 2 is equal to 10. Then we have 7 plus 1, oh, I'm sorry. Then we have 7 plus 1 is equal to 8. Then we have minus 8 plus 2 is equal to minus 6. Then we have 0 plus 0 is equal to 0. So once we get this answer, we got the value of A plus B. Now I hope the concept is very much clear to you. So that is exactly what we want, and the next step that we have to do is, we just have to check it once again, that I have this habit of checking once again. 7, 8, minus 5, 0, 10, 8, minus 6, 0. So the thing is that when we do it in mind, we always make it correct, but when I am explaining it in a class, there is a huge possibility that I make a mistake. So just recheck it once again. Now next what we have to do is we have to multiply this matrix with a C, right? We have to multiply this matrix with C. So now let's multiply A plus B into C. So let's write down C. So we know that C is going to be, I'll write C besides this one itself. So it is going to be 2, minus 2 and 3. Let's say what is the order of A plus B. The order of A plus B is going to be 3 by 3 and this is going to be 3 by 1. So we can say that we can very well do what? We can very well multiply these two matrices A plus B and C, and the resultant matrix will have the order 3 by 1. So let's write down the resultant matrix will be having the order 3 by 1. So that means it will have A11, A21 and A31. So this is going to be something called as column matrix, a matrix in which you have only one column and column and three different rows. Alright, so I hope the logic is clear. Now let's find out the answer, which is going to be A11 is first row into first column. So this is going to be 0 into 2, no matter. 7 into minus 2 is going to be minus 14. So this is going to be minus 14, and the next term is going to be 8 into 3 is 24. So minus 14 plus 24 is going to be equal to plus 10. So you get the answer to be plus 10. Now let's go for the next one. What is that going to be? Now that is going to be second row into first column. Second row into first column. That is going to be minus 5 into 2 is minus 10, and 0 into minus 2 is going to be 0, and 10 into 3 is 30. So we can say it is going to be minus 10 plus 30 is going to be equal to 20. So you get the answer to be 20. Now let's go for A31. That is third row into first column, which is going to be 8 into 2 is 16, minus 6 into minus 2 is 12. So 16 plus 12 is going to yield you 28, and that is going to be your final answer. So this is going to be your 10, 20 and 28 is going to be the answer for your LHS. Now we have to look for the answer for RHS. Now let's find out RHS. For instance, C plus BC. So let's find out AC plus BC first. So first I'm going to find out AC. Now AC, as you can see, this is going to be 3 by 3 matrix, and the next one is going to be 3 by 1 matrix. So AC is going to be a matrix of the order 3 by 1. So again, I'm going to write it as A11, A21 and A31. This is for AC. Let's do it this into this. First column into first row into first column is going to be 0, 6, 7 into 2 minus 2, 3. So 0 into 2 is 0. As I said, always do it on your own and use my class as just a verification of what you have already studied. So try doing it on your own. So it is going to be 6 into minus 2 is minus 12. 7 into 3 is 21. So minus 12 plus 21 is going to yield you how much? Minus 12 plus 21 is going to yield you 9. So that is going to be 9 in the first space, and the next is going to be 8 to 1, which is going to be second row into first column. That is minus 6 into 2 is minus 12. 0 into minus 2 is 0, of course. 8 into 3 is 24. So it is going to be minus 12 plus 24 is going to yield you another 12. So that is going to be 12, and A31 is going to be third row into first column. That is going to be 7 into 2 is 14. Minus 8 into minus 2 is 16, and this is going to yield me 0. So it is 14 plus 16, which is going to be equal to how much? 30. So you got the answer to be 30. So that is going to be your answer for AC. But we don't want to end up with AC. We want to go ahead for with which one? We want to go ahead with BC. Now let's find out BC. BC is again, it is going to be a 3 by 1 column matrix. So let's find out the answer here again. Your answer is going to be first row into first column. So that is going to be minus 2 plus 3, which is going to be equal to 1, and the next one is going to be second row into first column is going to be 2 plus 3, which is going to be equal to 6. This is going to be 2 plus, this is going to be 2, this is going to be 6, so 2 plus 6 is going to be 8. So this is going to yield me 8. And the next one is going to be third row into first column. Third row is going to be 1 into 2 is 2. 2 into minus 2 is minus 4, and 0 into 3 is going to be something else. So let me take the value. That is going to be 2 minus 4 is going to be equal to minus 2. So you got the answer to be minus 2. Now let's add these two together, shall we? Now let's add AC and BC together. So AC plus BC is going to yield you 9, 12 and 30 plus 1, 8 and minus 2. Let's add it. So what is going to be 9 plus 1? 9 plus 1 is going to yield you 10. Yes, it is going to yield you 10. Now what is going to be 12 plus 8? 12 plus 8 is going to be 20, and 30 plus minus 2 is going to be 28. So you got the answer to be 10, 20 and 28. Let's check the answer. Yes, you got 10, 12 and 28. So we got LHS is equal to RHS. You got LHS is equal to RHS. So I hope the concept is clear regarding the distributive property of matrix multiplication. So what we are actually doing is, while we are studying the property, we are doing more questions as such. Alright, that is why I actually use that, solve the properties and showed you how these things are going to work out. So I really hope the distributive properties has been very much clear to you. Next we will be looking into the concept of the third property, and the third property is regarding something called as, we studied something called as additive identity. Now what was additive identity? Additive identity is the concept in which you add something to a number, you yield the same number. That is the concept of additive identity. Now what is going to be multiplicative identity? You multiply a number with that number and you end up with the same number. In case of real numbers, it is going to be 1. That is, root 3 into 1 is going to yield you root 3. 5 into 1 is going to yield you 5. Minus 3 into 1 is going to yield you minus 3. That means that if you multiply a number with something, a number, such that you yield the same number as the answer. That is 1 for whom? For multiplication, 1 for division, 0 for addition and 0 for subtraction. That is the idea. 4 plus 0 is going to yield you 4. 4 minus 0 is going to yield you 4. That is the idea. So for what happens for that in the matrix case? In matrix, what is it that you can do? In matrix, what you do is that you multiply it by a identity matrix. We multiplied that by a identity matrix. So if you want to understand the concept of multiplicative identity, when you multiply a matrix with some matrix, okay, then I'm going to call it say X. Okay, I'm going to call it say X. So you are multiplying A and X, you should yield something called as A. Now what can you say about this X? That is the question. So X is going to be nothing but, it is going to be called as I, or that is an identity matrix. It is going to be called as identity identity matrix. You just remember what we studied about identity matrix and the different types of matrices. Just look at your notebook. We studied about types of matrices, right? When we were studying about the different types of matrices, we discussed about something called as identity matrix. And what was identity matrix? And it is going to be a special diagonal matrix in which diagonal elements are always equal to 1. All right, I really hope you remember. Diagonal elements is equal to 1. I know it is behind me, and what is written behind me? It is going to be diagonal elements is equal to 1. That is what is written behind me. All right, so there is you can see the diagonal elements is equal to 1. So when you multiply a matrix with 1, you will end up getting the same matrix. Say for instance, for that the condition is that this matrix should be what? It should be a square matrix. The condition is that this matrix A should be a square matrix. This should be a square matrix. So multiplicative identity exists only for square matrices. And what is that? That is going to be a identity matrix of the same order. Say for instance, A happens to be of the order 2 by 2, then you take your identity matrix is going to be another identity matrix of the order 2 by 2. Now assume that A is of the order 3 by 3. Then what is going to be your identity matrix? It is going to be an identity matrix of the order 3 by 3. That is the logic. That means that identity matrix will take the order of the adjacent matrix. Identity matrix will take the order of the adjacent matrix. So I hope the concept is very much clear to you. Alright. So once that concept is clear, now we understood the concept of identity matrix. So this is the concept, and I really hope that you understood the idea. So that means that you have a concept called as identity matrix, and that is going to be called as your multiplicative identity in terms of matrix multiplication. So this is the important property regarding multiplicative identity. And next comes the most important and the most confusing concept and the property which says AB not equal to BA. May or may not be. Okay. AB not equal to BA. There are situations where AB could be equal to BA. That means that you cannot predict AB could be equal to BA or AB not equal to BA depending upon certain situations. But in general, what do we say? We say AB not equal to BA. The difficult part is that you cannot even call this as a property. That means that AB equal to BA is also not correct. AB not equal to BA is also not correct, because there are situations where you can find AB equal to BA. There are situations where you can find AB not equal to BA. This is an extremely important concept. That means that when you are doing the multiplication 2 into 3 not equal to 3 into 2, it is exactly like saying like this. You see, 2 into 3 not equal to 3 into 2. That is exactly in that fashion. It is not exactly the same, but in that fashion. Alright. So that is the situation. Now we need to understand in very deep about this particular concept. So this is going to be an important theory part. So let's continue. You see, in order to prove AB not equal to BA, this is actually extremely simple way. First, we shall not even do a multiplication, and without doing a multiplication itself, we can actually prove that AB not equal to BA can happen. So first, I'll actually take the same examples that you have here in order to prove this. So first I'll take that you have something called as A, B and C. I'm taking two matrices B and C. So we'll try to multiply B with C, and you can see that the B is having the order of 3 by 3 and C is having the order of 3 by 1. That means that these two are equal, and you will end up getting the answer BC. But try to multiply C and B. That means that you just change it and try to multiply C and B. So that means that the first matrix is going to have the order 3 by 1 and the second matrix is going to have the order 3 by 3. So can this CB exist or not? Think of it, because our rule of multiplication says that if you have to multiply two matrices, then you write down the order first, and writing down the order, these two values should be equal. That is a basic condition for multiplication of matrices. You can see that when you write CB, that basic rule of multiplication is violated. So in that sense, you can say that CB will not even exist. That means that you cannot multiply matrix C and matrix B in that order. But if you change the order and you take BC, then you can actually multiply. So there are situations where we can say that AB can be found out and BA can sometimes be found out but may not be equal, but still there are situations where BA will not even exist at all. So that is the condition that you have to understand. The basic idea is when you multiply AB and you multiply BA, there is very less chance that AB will be equal to BA, and most likely that AB and BA might not even exist simultaneously. There will be situations where AB can exist and BA might not even exist. So we can say there are different possibilities in this, and the first first possibility I am writing down is AB can exist and BA can exist, but AB will not be equal to BA. This is one possibility. Another possibility is AB can exist, BA can exist, and AB will be equal to BA. This possibility can also exist. And there is a scenario where AB can exist but BA will not even exist at all. So these are three different possibilities that you can have. You can say AB and BA will exist but they are not equal. AB and BA exist, they are equal, and AB will exist but BA need not even exist. So that is why when I say this rule, but in most of the textbooks you can find that AB not equal to BA as a property. But we have to understand that that is a very incomplete statement when we say AB not equal to BA. That is a very incomplete statement. You have to understand this in detail. So in my opinion, this is the way in which you have to study this property. Even though in the textbook it is given in this manner, you have to study in this particular way. That will be a far more convincing way for you to understand this. So what we can say is that this property is basically called as commutative property of multiplication, right? This is the commutative property of matrix multiplication, and we can basically say that this does not apply. What can we say? We can basically say that this does not apply. So that means that they are not commutative. Matrix multiplication is not commutative. Very important concept. Matrix multiplication is not commutative. So that means that if you write a matrix multiplication, say if I write a matrix multiplication, say ABC, you cannot change the order. That is the most important thing that you have to understand. You cannot change the order in which matrices are written. Order in which matrices are written. That is the most important thing, or most important effect of something like commutative property not being existing. For example, when you are taking numbers, for instance, you can write 2 into 3 into 5 can be written as 2 into 5 into 3. There is no problem in that. Why is there no problem in that? Why do we say that 2 into 3 into 5 and 2 into 5 into 3 are equal? Why do we say? Because commutative property exists. Because commutative property exists. But when you don't have a commutative property, then ABC is not equal to BCA. They are not equal. There is no way possible that these will be equal. That is a very important logic that you have to, we can say a consequence of this one. Okay, when we are doing some problems, you can actually see that. When we say that matrix multiplication is not commutative, so what is the consequence of matrix multiplication not being commutative? So that consequence is what I am saying. That means that you have to always ensure that you have to write it in the same order, and changing the order will change the whole thing as such. Alright, so it's very important. Keep in mind that you cannot change the order. First thing. Say I can call this as consequence number 1. Now let's look for the consequence number 2. The second important consequence is that when we actually, the first one was just don't rearrange, and when we actually have a matrix like this, say if you have A is equal to BC, where A is a matrix, B is a matrix, and C is a matrix. So when we actually do a multiplication on both sides, okay, so here we are talking about multiplying a matrix on both sides, multiplying a matrix on both sides. These kind of questions can come, okay, both sides. So when such situations come, what we have to do is, if we are multiplying on the right side of this one, if we are multiplying on the right side of this one, say I am multiplying a matrix called as a P, if I am multiplying on the right side of this one, then we have to take the right side on this one also. Is that clear? Again, if I am having the same concept, say if I am having A is equal to BC itself, I am going to take A is equal to BC. If I am multiplying the new matrix, so I am having a new matrix, right? If I am multiplying the new matrix on the left side of BC, then you have to multiply the new matrix on the left side of A also. That means that these two are acceptable. You can see that you are having A is equal to BC was the original equation. The one marked in red color is the original equation, and the new matrix that I am introducing is P, and that is written in blue color. And you can notice that if P was multiplied on the right side of BC, then you have to multiply P on the right side of A. That means that multiplying on left side and right side has a difference, because you don't have commutative property. Similarly, you have A is equal to BC and you multiplied P on the left side of BC, means then you have to multiply P on the left side of A. Otherwise, you will end up not getting you will end up losing that equality. That means that if you actually do a multiplication of this sort, say you have A is equal to BC and you are having a multiplication of this sort, a P on the right side here and P on the left side here, cannot be accepted. This is a wrong way to do it. This is a wrong way. All right, this is a wrong way to do it. And what is wrong in this one? You can see that one p is on the right side and here the p is on the left side. That is not acceptable. All right, so I hope the logic is clear. These are the two consequences of commutative law. Okay, when you are doing a commutative law, this is the different consequences that you will have. Okay, so this is extremely important that you understand these consequences, because we will do more problems. When we start doing a lot of problems, you will be able to understand this. All right, so I really hope the properties of matrix multiplication has been extremely clear and the concept of matrix multiplication has been clear. So once it's done, we are moving on to the next topic, and the next topic is called as transpose of a matrix. Yes, this class has been so long, right? I know this class has been long, but don't worry, this is going to be a one-shot video in which we are discussing all the topics but two in very detailed way. All right, so we are going on to the next concept, which is called as transpose of a matrix. Now let's see what is transpose of a matrix. That is the next thing that I'm supposed to understand. So we are continuing with the next topic, which is going to be called as transpose of a matrix. Now let's see what do you mean by transpose of a matrix. So a matrix is going to be defined in the form, say A is equal to, say for example, I am having a matrix of the order m by n. Then A transpose is basically written as in two ways. Generally in some books you can see a T on top of the name of the matrix, or you can say A dash, in two ways in which it will be conveyed to you. In your NCERT textbook we are going ahead with A dash, but in certain books you can see that some books actually prefer to use T, and even some teachers use the concept of AT, which is going to be called as A transpose, or in other words you can say A dash is also A transpose in that sense. Alright, so I hope the representation is clear. Now what do you mean by transpose of a matrix? The concept of transpose is very simple. You interchange the rows and columns with each other. That means, what do you mean by transpose? What do? We interchange the rows and columns with each other. Now that's a confusing statement, right? Rows and columns, we interchange rows and column means, what do you mean by this statement? That is a doubtful thing to know. So let's see that. Say if I'm having a matrix, so as I said, you have a matrix of say m by n, and I'm taking another matrix, say B, which is of the order, which is going to be a standardized one, B of the order 2 by 3 matrix. So you can see a 2 by 3 matrix will have 2 rows and 3 columns. So it will be say A11, A12 and A13. It goes up to A23, right? A21, A22 and A23. So this is going to be your matrix, right? So this is going to be your 2 by 3 matrix. If I'm taking the transpose of this matrix, you can actually identify that, which is going to be my first row. My first row is going to be A11, A12 and A13. This is going to be my first row, and this is going to be my second row. So that means that when we say we interchange the rows and columns, it means that the first row becomes the first column. All right, what happens? Your first row becomes your first column. That is the idea. Alright, the first row becomes the first column. That means that these three terms, which is going to be elements, which is going to be A11, A12, A13, which was a part of first row, in B transpose, it becomes my first column. That means my first column is going to be something like this: A11, A12 and A13. And this is going to be a second row, and the second row becomes my second column. So this is going to be my second column is going to be A21, A22 and A23. So this is going to be the B transpose. Now you can also say we have interchanged. What did we do? We actually interchanged rows. We converted rows to columns. When we do that, we are automatically we are converting columns to rows itself. So you can see this is my first column, which was A11 and A21. That became my first row. Similarly, this is my second column. That became my second row. This was my third column, and this became my third row. That means that we have interchanged our rows and columns in their position. So this process is called as transpose of a matrix. This concept of interchanging between rows and columns is called as transpose of a matrix. Now let's see some examples of transpose of a matrix. So again, you can note that the order of this matrix was 2 by 3, and now the order has become 3 by 2. The order now has become 3 by 2. So that means that we have interchanged rows and column, means the order is also changing from 2 by 3 to 3 by 2. Similarly, firstly, what is going to be the A transpose? What is going to be the order of A transpose in your opinion? It was 2 by 3 earlier, became 3 by 2. That means that ulta ho gaya. It has become the ulta. So what do you think is going to happen to M by N? M by N will become N by M. M by N will become N by M. That is the logic of A transpose. I really hope this concept is clear. Let me take some examples and show that to you. Say, let me take one example. Say A is equal to 1, 4, minus 1, 2, 0, 2. Now this is going to be a matrix of the order 3 by 2. This is going to be a matrix of the order 3 by 2. So let's take another question. And I'm asking you to find out the value of A transpose. I'm asking you to find the value of A transpose. Now what is going to be A transpose? A transpose, the order is going to be 2 by 3. That means that my first row will become my first column. So 1, 2 is going to be my first column. My second row, 4, 0 is going to be my second column. Second row became my second column, and the third row became my third column. So that means that this is how my A transpose will look like. So the order was 3 by 2 in the first case, but when we took the transpose, we got it as 2 by 3. We can actually think about interchanging in terms of rows, or you can also think in terms of columns. That means that when you change rows to columns, automatically the other change is reflected. So I hope it is clear. So this is the concept of transpose, because transpose is actually a very simple concept and not a huge concept which is actually having a lot of applications. So this is, I think, has been extremely simple concept to you. Now there is an important concept also called as symmetric and skew symmetric matrices. Now that is an extremely important concept that is in a way connected to transpose. So let me see what is symmetric matrix. So let's just try to understand the concept of a symmetric matrix. So let's take, what do you mean by a symmetric matrix? A matrix in which you have a matrix whose transpose is equal to itself is called as a symmetric matrix. A matrix which is equal to its transpose, this is called as a symmetric matrix. I hope the logic is very much clear to you. A matrix whose symmetric, alright, so I hope the logic is very much clear. We can see that a matrix is equal to its transpose, then it is called as a symmetric matrix. Then there is another concept called as skew symmetric matrix. Now what do you mean by skew symmetric matrix? The concept of skew symmetric matrix is that A transpose is equal to minus A. That means that when you take the transpose of a matrix, you will end up getting the negative of that matrix. When you take the transpose of the matrix, you end up getting the negative of that matrix. So that is called as your skew symmetric matrix. So let us take some examples of symmetric and skew symmetric matrix. So you can see that in order to write a symmetric matrix, I am going to write it in a peculiar fashion. That means that I am going to write, say, 4, 3, 2. Now what I am going to do is, I am going to write minus 1 here, I am going to write minus 1 here. So I hope you notice the position. This position is, what is this position? This position is A12, and this position happens to be A21. Now I am going to write another thing which is going to be 0. I am going to write a 0 here. This position is going to be A13. This is going to be A31. Alright, now I am going to write the last one number, and that is going to be 1 and 1. Now you got that this position is A23 and this position is A32. Now let's take A transpose. Let's take A transpose and let me see what we will get. We get your first row happens to be 4 minus 1 0. Let us write that as my first column. Now that is going to be 4 minus 1 0. You can see the first column is going to be same. Now let's take minus 1 3 1. That is my second row became my minus 1 3 1 became my second row became my second column, and my third row 0 1 2 is becoming my third column. So now you can see that we have just converted A into A transpose, but we ended up getting the same matrix. So that is the concept of symmetric matrices. Certain matrices are like that. That means that the matrix will be equal to its transpose. Now we will just highlight the two terms. So you can see these two terms must be equal. Also these two terms must be equal, and also these two terms must be equal. And the diagonal elements can be anything. There is no condition for diagonal elements. That is how you write a symmetric matrix. So your doubt will be like, if someone asks you to actually make a symmetric matrix, how do you make a symmetric matrix as such? Alright, there is a confusion that you may have. How can you make a symmetric matrix? If I ask you to write a symmetric matrix, what you have to do is you can fill the diagonal elements as your wish. You can write it in any way you want. But you ensure that these two terms are same, you ensure that these two terms are same, and you ensure that these two terms are same. The number number is not a problem, but you have to ensure that these two are same. That is the logic. The number is not important, but the position is important. If you actually fill in this particular format, you will end up getting the like this. All right, is that concept very much clear to you? Now shall we go ahead and write for the concept of skew symmetric matrix? Yes, I think we shall go and write the concept of skew symmetric matrix now. Before doing that, I'll just move from one side to other side so I can have enough space for you. All right, fine. So again, I'm going to write a matrix here. I'm going to write a matrix and I'm going to fill it in such a way that my diagonal elements are given to be equal to 0. My diagonal elements are given to be equal to 0. Here I'm going to write 2. Here I'm going to write this position is going to be given the number 2. So this position is going to be given minus 2. This position is given 5 and this position is given minus 5. This position is given 1, so this position is going to be given minus 1. So this is how you will write a skew symmetric matrix. This is how you will write a skew symmetric matrix. Let me write it for you once and for all. So this is going to be 5. Yes, very good. So this is going to be 5. So I really hope the logic is clear. Now let me explain to you how that is being filled. How did I actually fill it? Again, you can see that there is a condition for diagonal matrices, and the condition is that all the diagonal elements must be 0. That means that for a skew symmetric matrix, all the diagonal elements will always be equal to 0. And what is the next condition? You can see that in symmetric matrix, these two were equal. But here you can see these two are not equal. Instead, they are opposite to each other. They have the same magnitude but opposite sign. If this happens to be 2, this should be minus 2. If this was minus 4, if this was minus 4, it should be 4 in that sense. Alright, it should be the negative of the number in that position. Similar is applicable for this number or this position also. You can see that this is 5 and this becomes minus 5. And also one more thing is remaining for this position. You had minus 1, here you have 1. That is the logic. I hope the concept is very much clear to you. If there is any doubt, you know what to do. You can just message me in any way you want. So this is going to be the concept of skew symmetric matrix. So we just discussed about the concept of transpose of a matrix, symmetric matrix and skew symmetric matrix in these concepts. Alright. So I really hope this video has been completely helpful for you. We've discussed all the aspects of the chapter matrices. Of course, this is not enough for you. You will have to solve more number of problems, especially from symmetric, skew symmetric, transpose, as well as the earlier concepts, right? Earlier concept of multiplication, and from this one also regarding the properties of matrices and all. You need to solve many problems as such. The solutions for all the questions from NCERT as well as NCERT exemplar is available in our application. So really you can follow that, and I really hope this class has been helpful for you. And if this was useful, please ensure that you subscribe to our channel and like the video, and you can put in your opinions about the classes in the comment section. So I really hope to see those comments, and I think it'll make, I really hope that it helps and makes me happy also. So to know more details about the courses that is conducted in Math Academy, you may visit our website. The link to the website is given in the description. So I really thank everyone once again, and to the last time it is my thank you. And again, I'll be seeing you with more such videos and more such classes as soon as possible in once again in another video. Till then, it is me, Nikhil, signing off from Math Academy. It's a goodbye.